Good morning, everybody. I am very happy that I can start this section number 6 with name Mechanical Engineering 1. Let me introduce myself very briefly. My name is Milan Edl. I am from University of West Bohemia, Faculty of Mechanical Engineering, Department of Industrial Engineering and Management from the Czech Republic, and I greet you to your universities, your offices, and I am looking forward to presentation. This presentation will be 8, I hope, and one presentation approximately 10 minutes for you. I think in this time we play short video clip.
Hello, ladies and gentlemen, my name is Konstantin, and let me introduce our research dedicated to the topic, which is called the simulation of the shaft surface strengthening as a result of discrete electromechanical processing. Thank you for watching. Okay, let's start from the introduction and major challenges. First of all, let's talk about the problem of the modern vehicle's weight, based on the classic example of the Volkswagen Golf of the first generation, which was actually just 790 kilograms, and the current one, 8th generation, grew up to 1,400 kilograms. Thus, the components such as a shaft must withstand significantly higher loads, which is why the surface strengthening technologies like the suggested EMP, electromechanical processing, are becoming relevant. Another point is the major challenge addressed by the research is the complexity of EMP simulation, which involves a combination of thermal and mechanical loads. This complexity is compounded by the need to model these interactions accurately in ANSYS or another VA environment with precious boundary conditions and a deep understanding of the material behavior. What are the aims and research tasks? First of all, the task was to simulate and investigate the process of discrete electromechanical processing, so-called EMP, for the surface strengthening of the shafts. The study aims to develop a robust mathematical and ANSYS model to predict stresses and evaluate the effectiveness of EMP. Another task was to predict the depths and the location of so-called white layer, which is a finely dispersed and hard surface structure that is crucial for enhancing the mechanical properties of the shaft. And finally, to propose the new mathematical algorithms that complement traditional VA methods, making stress prediction more efficient and accurate. Let's talk about the research methodology and start from the first subtask, which is called the mechanical contact analysis. Actually, it is dedicated to the modeling the dynamics of the roller loaded contact with the shaft and evaluation of the surface plastic deformations, so-called SPD, in the ANSYS static structural environment. The cylinder represented by the shaft and the torus corresponding to the pressure roller. A model consists of the roller with a diameter of 60 mm and the radius of the working surface of 2.5 mm. The shaft had the diameter of 25 mm. Among the boundary conditions were applied the next ones. First of all, the force which was acting on the upper part of the rod, which is marked by tag B, with the growth from 0 Newton to the max value. There were considered both cases of 1000 Newton and 4000 Newtons during the first second. The second point of the boundary conditions was the rotational velocity of 10 degrees per second and the rotational angle of 30 degrees. They are marked with the tag A. Third point was dedicated to the constraints. Among of them there were the revolute joint for the roller and remote displacement, tag C for the geometric center of the shaft. Finally, 22 degrees per Celsius temperature was applied to the model and the friction coefficient of 0.1. Used material of the shaft was steel S235. The second part of our research was dedicated to the thermomechanical contact analysis. It aimed at evaluating the influence of material nonlinearity and temperature load on the results of stresses and deformations. Therefore, the separate solid model of the contact spot with geometric parameters which were determined based on the results of the previous task was designed. It has a small area surface of just 4.2 per 1.8 millimeters with a depth of 0.3 millimeters. This model of spot was meshed with a finite element size of just 0.05 millimeters. Among the boundary conditions were applied the next ones. First of all, the bilinear isotropic hardening for the non-linear material properties in the ANSYS. The thermal load of 900 degrees per Celsius applied to the contact spot and the convention of 25 watt per square meter per Celsius with the force of just 400 newtons, which is actually 10 times smaller than in the results of the previous problem. And finally, the experiment time duration of the 4 steps, applying the force from the 0 to 400, stabilization of it and reduction to 0, and keeping 0 force in the last 4 seconds of the experiment. Mathematical modeling algorithms. The mathematical modeling predicting von Mises stress is of great interest as well, because unlike the Phi-A environments, it is less resource intensive. So at first point, let's assume a steady state heat transfer in the contact area and use the heat conduction equation in the cylindrical coordinates. It will correspond to the case of our shaft in contact with a roller, considering the high temperature effects on thermal conductivity. The second step of our mathematical modeling algorithm is based on finding the temperature change obtained from the heat transfer analysis, so it's possible to calculate the stress due to the thermal expansion. After this, it's possible to use the Rambo-Osgood model, which fundamentally alters how we calculate the contact stress components due to its focus on the nonlinear stress-strain relationship. So finally, it's possible to summarize the obtained previously parameters and combine them together in the updated von Mises theory. It's possible to consider the combined effect of mechanical load and thermal expansion. The results of the mechanical contact analysis. The maximum displacements of 15.67 millimeters were found on the outer surface of the roller as a result of its rotation. The vertical movement under the force of 4,000 newtons were 0.143 millimeters and 0.119 under the force of 1,000 newtons. The maximum overall stress was 521 megapascals, and it was recorded on the surface shaft at the moment of time of 2.15 seconds. The contact status and the maximum stresses fluctuate during the experiment. The reason lies in the friction of the contact pairs, which caused by thermal expansion. The status of the ANSYS contact tool shows the results on the graph. Let's get acquainted with the results of thermomechanical contact analysis. The overall highest stress during the experiment was 1082 megapascals, and it was gained at the moment of time 2.0 seconds, while the force still maintained the value of 400 newtons. The transient moments of time are of quite interest as well. For example, at the early stage of the experiment, at the moment of time of 0.01 second, the stress has already gained the value of 996 megapascals. the roller captures a certain part of the shaft of its surface with its contact and transmits the load to the rest of the shaft through it. This process can be called the instant sticking of the roller to the shaft in the microregion. Let's investigate the next transient moment of time at the stage of the first second of experiment. The von Mises stress has gained the value of 1058 megapascals when the load reached 400 newtons. The extremum of the stress has migrated to the depths of the surface about 0.1 millimeters, where under the conditions of temperature the appropriate white label began to form. This actually corresponds to the deformation process of the metal surface, where the typical depth of the white layer is around 0.2 millimeters. At the moment of time 2.0 seconds, the maximum overall stress of 1082 megapascals was gained and the force maintained at 400 newtons. Thus, the system has accumulated maximum energy. During the next steps of time, the force linearly decreases to zero, and therefore the turbulent process appears in the structure of the outer layer. So the max stress returns to the surface of the shaft. So let's finally investigate the final moment of the stress loading of our model. At the moment of time 4.0 seconds, the stress was at the level of 1036 megapascals. Actually, it's a residual stress while the force remains zero. So the shaft is not subjected to the load and the plastic deformations are stabilized. This results clearly indicates the strengthening of the upper layer. Let's sum up the conclusions. First of all, the proposed mathematical algorithms for predicting the maximum stress as a result of mechanical and thermal loads prove the feasibility of considering the Ramber-Osgood model and actually cannot be based on the Hooke's law. Additionally, obtained thermal stress complements the von Mises theory efficiently for approximation of the finite element results, though there is a drawback. It doesn't allow predicting the depth of the white layer, where the max stresses are formed as a result of EMP at the depth of 0.1–0.2 millimeters. The second conclusion is dedicated to the SPD case. So despite the slight difference in vertical movements of the rod, the magnitude of the max stress varies considerably from 521 to 130 megapascals, while reducing the applied force from 4,000 newtons to 1,000 newtons. And actually, the last value of 130 megapascals is below the yield point, and this allows to achieve surface hardening with insufficiently high rolling load. And the final conclusion is actually dedicated to the EMP, when the model being 10 times less loaded, 400 newtons, but heated up to 900 degrees in the contact spot point, so the model has demonstrated twice the stress at the level of 1082 megapascals. The thermal load, together with the material nonlinearity, significantly affects the formation of the white layer at a depth of around 0.2 millimeters, and the residual stress was 1036 megapascals. It was in the absence of the loads on the shaft, and actually this confirms the preservation of the white layer. Dear ladies and gentlemen, thank you for your attention and for getting involved into our common research. Bye.
Dynamics analysis of elevator winches with thyristor control system. Elevator is a means of transportation that is used as a mean of vertical transportation in a high building. An elevator is used to transport people or goods. However, elevator malfunctions pose a huge threat on the safety of life and property, as well as the normal travel of users. Efficient vertical transportation is vital to a skyscraper's functional operation and the convenience and satisfaction of its tenants. The task of the research is to ensure the accuracy of the specified motion law of the cap within the operating cycle, which is required by the terms of the safety rules. The aim to obtain standardized modes of a passenger elevator are universal for all elevator winches of traditional design, with a worm gearbox, a two-speed asynchronous motor, and a thyristor control system. Research tasks to analyze the dynamic operating modes of a traditional elevator winch with a worm gear, a two-speed asynchronous motor, and a thyristor control system. Let's consider the dynamics of the elevator winch with a worm gearbox, a two-speed asynchronous motor, and a thyristor voltage converter. To do this, it is advisable to solve the problem of implementing the optimal law of cabin motion, which should ensure implementation of acceleration and jerk. One of the most important reasons is that in order to achieve high economic efficiency, it is advisable to make a thyristor electric drive with the simplest structure and therefore with limited capabilities in terms of the formation of dynamic characteristics. In this regard, one should focus not on the optimal law of the motion, but on one close to the optimal one, which can be obtained by changing the moment of the motor during start-up and deceleration, and taking into account the need to limit the magnitude of acceleration and jerk. The maximum value of cabin acceleration at start-up can be found. A maximum deceleration value, then stopping, taking into account a direct energy transmission through the gearbox. And during reserve energy transfer. The maximum value of the jerk should be expected with the abrupt change in the acceleration or deceleration torque. Therefore, to limit the maximum value of the jerk, the torque must be changed incrementally. When starting up, if the torque changes according to the expression, the moment of the asynchronous motor changes according to expression, and the delay time can be found. Substituting these expressions into the cabin motion equation. Taking into account the replacement, differentiating this expression twice, taking into account the corresponding substitutions, determines the maximum value of the cabin jack. In a similar way, you can find the maximum value of the jerk at other times of the cabin motion cycle. In this case, the main influence of the magnitude of the jerk will be exacted by the change in edging torque. The calculation of the parameters of the dynamic characteristics of an elevator system with a thyristor voltage converter can be illustrated using the example of the study's lifting mechanism of a passenger elevator with the parameters given in table. The general view of the winch is shown in figure. The main parameters of the dynamic characteristics that influence the conditions of comfortable movement of the cabin are calculated. A diagram of changes in winch torque and resistance torque during the switching cycle. It was experimentally determined that in uncontrolled mode the normalized average values of cabin acceleration are maintained only during startup. When braking, the acceleration is almost twice as high as normal. Even greater acceleration occurs in the initial phases of starting and braking the cabin. The significant influence of the dynamics of the elevator lifting mechanism of electromagnetic transient processes in the drive asynchronous winch motor when windings of both high and low speed are connected to the network has been experimentally confirmed. To illustrate this influence, the dynamic mechanical characteristics of the winch in question can be used in the cycle of traveling one floor up and going down at a nominal cabin load. When operating a traditional gate elevator hoisting mechanism with a non-adjustable control system. The normalized average car acceleration values are maintained only during startup. When braking, accelerations are 13 to 100% higher than the normalized values. Even greater acceleration values, more than normalized by 100 to 150% in the initial phases of start and braking the lifting mechanism motor. When using an adjustable thyristor control system, the maximum acceleration values of a passenger elevator car in the start-up mode are 70 to 100% less when the maximum permissible values over the entire load range, and change relatively little, up to 5 to 15 over the entire start-up time range. It is possible to limit not only the maximum acceleration value, but also the jack. The lag time for the start of movement is relatively small, which does not affect the performance of the elevator and limit its operating characteristics. The obtained patterns for the formation of control actions in order to obtain a standardized mode of a passenger elevator are universal for all elevator winches of traditional design, with a worm gearbox, a two-speed asynchronous motor, and a thyristor control system. Thank you for your attention.
I welcome the participants of the international conference InterPartner-2024. I would like to thank the organizers of the conference for the opportunity to present the result of our research in the topic, qualitative states moment models of operation fluid in the chamber of the auto-balancing device. Ensuring a low vibration level of rotary machines and technological process is one of the main conditions for their quality and reliability. Usually, no method of static and dynamic balancing are used for such machines. However, there is a large class of machines in which the imbalance constantly change. For such machines, automatic balancing is most effective. When passive corrective bodies track the chain in imbalance and try to maintain equilibrium with then moment. This method of balancing is important and necessary for practice. Repeat type self-balances have a number of advantages. Such ABD can be made of such size then ensure full compensation of the most possible imbalance in the system. However, they do not provide complete balancing as they require a residual imbalance. From the analysis of classic theory, it is now that the basis of the operation of liquid self-balancers and the phenomenon of self-centering of the rotor. This phenomenon occurs for flexible rotor system in the supercritical range of rotation speeds. Therefore, the subcritical mode of motion of the rotor system is not considered. Research is limited to studying the vertical rotor system. The purpose of this study is to investigate the behavior of the working fluid in the subcritical range and determine the properties of its motion modes. The case of a rotor system with a non-vertical axis is considered. Experimental studies were carried out by measuring and vibration amplitudes of rotor installation and by direct visual observation. Slides 5 and 6 show the equipment used special stand with developed experimental samples of the ABD and installation simulating rotors on elastic supports with vertical and horizontal axis of rotation and axis inclined at an angle to the horizon line. Experimental studies were carried out using the method of high-speed video recording of the behavior of the working fluid in the ABD chamber on specially designed stands with measuring and video equipment. Theoretical studies began with the generalization of the problem of the shape of the free surface of the liquid in a cylindrical chamber of radius r and height h of the self-balancing device for the case when the rotor with ABD rotates with an angular velocity omega around its axis at an angle alpha to the horizon. The question 1, it is the equation of the free surface of the liquid was obtained by integrating the differential equation of fluid equilibrium in Euler form. Equation 1 determines of the location of the free surface of the liquid in the cylindrical chamber of the ABD depending in the values of the angular velocity. This allows us to distinguish four modes of moment of the working fluid. Expression 2 is an estimate of the angular velocity of the inclusion of the liquid volume in the rotation motion. She characterizes the fourth mode of moment of the working fluid. In the case of operation of liquid ABDs for rotors with a non-vertical axis. The working fluid is subject to the simultaneous action of gravity fields, friction forces, and centrifugal forces. The vector relation between the forces factors make it possible to determine the minimum speed for the force mode of fluid movement. It is expression 3, and provide a physical explanation of the conditions for the existence of 4 modes of fluid movement in the ABD chamber. Schemas of vector relations between power factors and accompanied by examples of video frames with the location of the working fluid for the corresponding speeds for rotation of the rotor of the experimental installation. The first mode, figure 5, the mode full priority of gravity. The second mode, figure 6, the mode partial priority of gravity. When the liquid under the influence of the net force effect performs a circulation movement with a shield of the center of mass in the direction of the rotational movement of the chamber. The third mode, figure 7, the mode partial priority of the centrifugal force. But the action of the centrifugal force, which increases friction, is not enough to oppose the gravitational component of the net force. The liquid loses contact with the chamber wall, falls and floats to a lower point. In the fourth mode of the moment, the enter liquid jumps into rotation and is distributed throughout the chamber in a layer of uniform thickness, provided there is no eccentricity of the masses. Figure 8. The fourth mode account when the vector sum of the centrifugal force and frictional force exceeds the gravitational component. In this case, vertical and non-vertical rotor system operate in the same way. The calculated at observed values of the estimates of the corresponding angular velocities are summarized in the table this slide. The difference between theoretical and experimental results can be explained by not taking into account the viscosity of the working fluid in the model. After reaching the angle speeds at which the fluid is included in the rotary motion of the rotor system, the fluid is gradually involved in the automatic balancing process. In conclusion, the considered task is the initial stage of substituting the work of a liquid autobalancing for a rotor system with a non-vertical axis. The simulation results make it possible to make a reasonable comparative analysis of the behavior of the working fluid for rotor systems with different angles of inclination of the axis of rotation in the subcritical range of rotation speeds. The main results of the study are present of this slide. Thank you for your attention.
Hello, dear participants. My name is Nadia Fatieva. I represent a research team from National Technical University Kharkiv Polytechnic Institute and Metromotorny Tavria State Agrotechnological University. Among my colleagues are Alexander Fatiev, Sergei Sushkov, Vasil Metkov, and Valery Polyakov. In our current research, we are focusing on a method of accelerated tests of axial piston pumps by intensification on fatigue damage accumulation process. The level of modern hydraulic system places high demands on hydraulic equipment to produce quality in the shortest time possible. This causes the need for continuous improvement of constructions, application of new materials for manufacturing and coating of parts, acceleration of design and development of new models of hydraulic machines. The main element of the hydraulic system is the pump, the reliability of which largely determines the reliability parameters of the entire hydraulic system. In order to ensure a high level of pump quality, it is necessary to carry out tests at different stages of production: design and prototype development, construction modernization, development of new pump models. Since most of the time is spent on testing, the urgent task is to reduce testing time and improve the quality of hydraulic equipment. Implementation of accelerated tests allows to shorten the period of creation and finalization of new pumps, reduce the duration and cost of periodic and technological testing, accelerate the implementation of measures to increase the reliability and useful life of pumps in the process of serial production and modernization. The aim of this work is to evaluate the factors determining pump longevity while ensuring the equivalence of accelerated and long-duration resource testing of pumps. Axial piston pumps are complex mechanical engineering products. The resource exhaustion of their details is determined by various factors, qualitative and quantitative characteristics. To analyze and evaluate the technical condition of the details after long duration and accelerated test, the details are divided into three groups. The first group is details whose useful life is determined by their fatigue strength and depends on outlet pressure and pump shaft rotational frequency, such as drive shaft, pistons, and bearings. The second group is details of friction pairs whose useful life is determined by their wear, resistance, and other factors, and depends on outlet pressure and pump shaft rotational frequency, such as piston bushing, slipper pad swash plate, and distribution details. The third group is details whose useful life is independent of partially dependent on the outlet pressure and for which longevity is determined by the pump shaft rotational frequency, piston slipper pad, retaining plate slipper pad, and valve springs. This methodology involves ensuring equivalence between accelerated and long-duration tests. For the first group of details based on the equality of accumulated damage, the required equivalent number of loading cycles at increased pressure of accelerated test and the required test time are determined by calculation. For the second and third groups of details, the equivalence is determined by the similarity of the technical condition of details that have passed accelerated test and details that have worked during long-duration test for a time equal to the time of accelerated test. The pump run time at increased pressure is taken from the detail of the first group requiring the longest time for equivalent test. The possibility of operation beyond the specified time without failure of the other details of the first group is determined by calculation based on the values of the fatigue strength reserve. Where the operation time is severely limited by the fatigue strength on the details, special measures must be taken. For example, replacing with details during testing after the specified time has elapsed. In specific cases, these points should be reflected in the test program. Based on this methodology, an accelerated live test program is drawn up for each pump. Two approaches can be adopted to determine the acceleration test modes. The following parameters are taken into account during the test: outlet pressure, pump drive shaft rotational frequency, and acceleration coefficient. Depending on whether there is no or a priori information on the nature of the influence of increased operation modes of the pump on its technical condition, we consider two cases. First, the acceleration coefficient is set. The values of increased pressure and rotational frequency are determined by calculation. The acceptability of the calculated modes is taken experimentally based on the experimental results. If necessary, the modes are corrected. Second, the extent to which the pump operation modes are shaped during accelerated tests is determined from previous experiments with the pump's operation at increased pressure and rotational frequencies. The accelerated test time and the acceleration coefficient are then calculated. For the types of axial piston pumps considered in the methodology, on the basis of a priori information, for accelerated test the degree of pressure boost of 25% and speed boost of 20% is accepted in relation to nominal ones. This methodology adopts two concepts of acceleration coefficient. First, acceleration coefficient for the first group of details. Second, acceleration coefficient for the pump as a whole. And total time of accelerated testing is. This testing period has a purpose. First, to increase the size of the actual contacting surfaces of the details of the second group, i.e. to ensure the running in of the friction pairs for the perception of high specific pressures arising at forcing by the outlet pressure. Second, to obtain for the total time of accelerated testing the values of wear on the details of the second group, which can be measured by generally accepted methods with sufficient accuracy. Third, to obtain for the total time of accelerated testing the exposure of the details of the third group to a greater number of cycles for a more accurate assessment of the technical condition of these details. Pumps subject to accelerated tests shall be manufactured in strict accordance with the drawings and specifications. During the test, measurements of the pump effective flow rate at nominal modes shall be made at intervals to be specified in the test program. At the end of the test, the effective flow rate is measured, the pump is disassembled, and the main components are micromelted to compare with the date in the table on the 8th slide, but more on that later. Two types of failures are possible during tests. The first type of failures are failures that are eliminated by current repair, after which the tests are continued taking into account the previous operation time. The second type of failures are failures for which it is stated that the pump has reached its limit state, which requires a special repair according to the manufacturer's technology. The safety factor is determined using the fatigue strength curve of the details as depends on the mode of operation of the detail. For modes of unlimited duration, the number of cycles for the useful life of the detail is greater than the base number of cycles. The safety factor is defined in relation to the endurance limit of the detail. And for modes of limited duration with stress above the endurance limit, point G in figure, the safety factor is defined in relation to the stress on the fatigue strength curve of the detail. Also, for limited duration modes, the safety factor is determined by this formula and depends on base number of cycles in test with a given normal stress, maximum permissible pressure, pressure causing stress corresponding to a given number of cycles on the fatigue curve. For modes of unlimited duration of work, the number of cycles required for accelerated tests of the detail is determined by the formula and depends on maximum permissible pressure, pressure during accelerated tests, and tensile strength of the detail material. And finally, the time of accelerated test is determined by this formula and depends on two: maximum permissible pressure, pressure during accelerated test, tensile strength of the detail material, and pump shaft rotational frequency during accelerated tests. The final stage of the accelerated test is to compare the technical condition of the pumps that have passed the accelerated test with the date in table on the slide, and to draw a conclusion of the result of the tests. Accelerated tests fully reproduce the technical condition of the first group of pump details in terms of accumulated damage compared to long-duration, full useful life tests. It is not possible to reproduce the technical condition of the second and third groups of details in the short time of accelerated test. Therefore, the wear value of the main details that have undergone accelerated test are compared with those that have undergone long-duration test for a time equal to the accelerated test time. Data on the technical condition of the pumps and their component after the first 1000 hours of operation during useful life tests at nominal modes are presented in table. See on the slide. The comparison is made on the basis of functional parameter and structural parameters of the details. For comparison, the reduced wear of the accelerated test details, which takes into account the effect on wear of the increase in the friction path per unit of time during accelerated test, should be used. The effect of pressure increase on wear is not taken into account due to a significantly smaller effect than the rotational speed. When determining the effective flow rate for a pump with significant dead volume, the ratios given in ISO 4409-2019 are used. Due to the variety of factors affecting the wear of pump details, it is not possible to obtain a completely identical technical condition between two details that have been in service for the same length of time, even under exactly the same conditions. Therefore, when comparing pumps that have undergone accelerated and long-duration test, there will be some discrepancy in the parameters compared, the extent of which is used to conclude a positive pump passed the test or negative pump failed the test. A positive result of the conducted test can be considered if none of the second type of failure occurred during the testing process, if no fundamentally new defects are found during the examination of the developed pump, if the parameters of the technical condition of the pump after the tests deviate from the parameters of table slide 8 by no more than 50% upwards. This methodology can be used as a guide for accelerated test on PA-type axial piston pumps, regulated and non-regulated with valve distribution at 320 bar, regulated pumps with end distribution at 200 bar, and regulated pumps with end distribution at 160 bar. The author planned future research to extend this methodology to axial piston pumps operation at 450 bar. It is worthwhile to consider the effect of increasing pressure on wheel in future researches. Do not hesitate to contact us if you have any questions, and thank you for your attention.
Dear colleagues, organizers and participants of the InterPartner-2024 conference, the materials of the conference paper with the title Development and Substantiation of Proposal for Modernization of Plate Rolling Mill are brought to your attention. Information about authors. Dr. Alexander Kurpe, as a Doctor of Technical Science, represents Metinvest Engineering, and this is Design and Development Firm. And Professor Volodymyr Kuchar, that's me, represents the Technical University Metinvest Polytechnic. Modern market conditions require the diversification of rolling mills product mix productions. It can be seen from the examples of the known graphs that when expanded the product range, the strategy to reduce costs per unit to productions, e.g. 1 ton of steel, 1 slab, etc., can be implemented. One of the methods for these problems decisions is the modernization of existing rolling mills equipment. Contemporary requirements for the product range are new plates, dimensions, new steel grades, high mechanical properties of steel products, and of course high quality products at lower operation costs. Beside other, the target parameters for the produce and mix of Ferriera Valsider plant in Italy, plate rolling mill after modernization are the thickness range of from 5 to 150 millimeters and highest range steel grade like S900 MC according to the European norm standard. One of the other conditions for the modernization of the existing plate rolling mill at Ferriera Valsider plant is to be rolls weight which will be maintained by the existing cranes. So weight of one of backup or walk roll do not exceed existing cranes load capacity of 80 ton. Thereby, the basic problem is searching of such characteristics of plate rolling mills that will satisfy the listed conditions. Two high plate rolling mill have some technical limits related to the rigidity of the mill stand design, which slow down the expansions of the product mix by dimensions and steel grades, and also have some limits in the productivity and quality of products that are produced in this mill. At present, during the productions of steel plates in Ferriera Valsider plant, two high rolling mills is still in use. The parameters of this rolling mill unit limit the further development of plate production of the plant. Taking into account that rolling shop infrastructure already exists, there are some limitations in the new rolling stand design. When calculating new stand parameters, crane's load capacity must be considered, which will allow significant saving during the modernization project implementation. On the other hand, the four high rolling mills have a number of advantages. Modern four high rolling mills for the plate productions have a complex systems that provide the geometric forms of rolled products, improves quality, and increases rolling productivity. If one compares rolling mills with different parameters, including 2 and 4 high mills, their configurations enable them to produce the same product mix. Which of these rolling mills is more efficient? Which complex parameters or criterion will allow us to define it better? That's assignment research task. The task of this complex research is to develop the structural and plate rolling mill parameters that will allow to produce target product mix and define which of the rolling mills options is more effective for full fulfillment of the set goals for the production of plates with a thickness from 5 to 150 millimeters and of steel grades up S900MC with limited conditions of grains load capacity in Ferriera-Valsidra plant. The assigned task of calculation the necessary parameters of structurals of the rolling mills is solved by using mathematical modeling. Before given the limited conditions of the existing production, it is necessary to find a balance between the rolling mills parameters and the quality of the products that will be produced on the rolling mill after modernization. The scheme of the Valsidra plant main equipment shown in the figure 1. The plant consists of two consecutive production lines, the first and the second. The first is a line of hot rolled plate productions and semi-finished rolled product production, the Stekel mill. The second includes the following main equipment. Position 5. The 6-zone pusher type reheating furnace for heating of slab which is heated with natural gas. Position 4. The rolling mills 3170 for rolling of plates and semi-finished rolled products for the Stekel mill, which includes two high stand with a rolling force up to 25 meganewtons. Position 3 is the Ager rolling mill. Position 2 the leveling machine for hot plate. Position 1 is a cooling bed. The line 2 for the hot rolled coil productions includes the following main equipment. Position 6 the 7-zone pusher type roller heat furnace for intermediate heating of semi-finished rolled products which are heated with natural gas. Position 7 the Stekel mill, which includes 4 high stand 1000 and 780 with the rolling force up to 24 meganewton, and 2 cooling furnace with which are heated with a natural gas. A laminar cooling system, this is position number 9, which allows to accelerate cooling of metal after rolling on the Stekel mill at the rate of the up to 4 Celsius degree per second. And position 10, the coiler to coil a strip with thickness up to 20 millimeters. The given research relates to the line for the hot rolled plate productions. The rolling mill 3170 has the following parameters that shown in the table 1. The actual product mix includes the plate with dimensions from the 12 to 200 millimeters in thickness, from the 1500 to 3000 millimeters in width, from the 4000 to 24,000 millimeters in length, of steel grades from S235GR, SIE 1006, steels from shipbuildings to steel grade C45, 30 Magnus B5 and others. All hot rolled plates are produced in following conditions: as rolled, normalized in furnace, annealed. The quality of hot rolled plate is limited to the requirement of the European Normale and American STM standards. The crane, which maintains the rolling equipment in the mill bay, in particular rolls Rainwell, has load capacity of 80 tons. This parameter is constant throughout the research. The actual parameters of main rolling equipment restrict the product mix development, including the possibility of product plates with less thickness tolerance, for example, the half thickness of tolerance of European normal. better internal and external quality, stable mechanical properties and applying rolling conditions such as thermomechanical controlled process (TMCP) in high and low temperature range. Also, for TMCP plates, productions with high temperature range laminar cooling systems is required. Inter alia, the preliminary analysis showed the actual rolling force, which depended of diameter and number of work rolls, limits the level of engineering strain, number of passes, rolling temperature. The requirements for the target product mix are follows. Thickness range from 5 to 150 millimeters. Steel grades up to S900 MC, half of the European norm thickness tolerance. For modernization of plate production on Ferriera-Valsidra plant, two options are considered. The first option is installation of two high rolling mills with increased rolls diameters. The second option is installations of four high rolling mills. To compare both the options proposed, the actual two high rolling mills, one has defined main mills parameters. Using these parameters, one has calculated rolling schedules for the hard product mix produced from steel grades S900 MC for the plate with same dimensions. The target of the rolling schedules was to obtain the minimum thickness which is possible to reach after rolling in these mills accounting these parameters. The results are given in table 2. In options 2, the applied rolling force is more effective because the smaller work rolls diameters and respectively less contact area between the metal and rolls. Comparison of the rolling technological parameters at the rolling mills was obtained by simulation of plate rolling process of steel by options shown in the figure 2. Among the option 1 and option 2, the four high rolling mills more preferred because it's enabled to produce less thickness of reference steel grade for fewer passes number, more engineering strain, and provides better final quality. Also, rolling mill parameters in option 2 provide more capacity, product volume per year, and lower electricity consumption. To evaluate the effectiveness of applying the rolling force by options 1 suggested force ratio, Phi force, that's shown the value of rolling force necessary for 1% reductions at the mill. The comparison of the Phi force change depending on thickness by passes and the options in the shown on the figure 3, which confirms that applying rolling force to the four high rolling mills is more efficient, since 1% reductions requires less rolling force. The comparisons of the average Phi force by passes and by options has shown that the efficiency of using the rolling mills with option 2 parameters is 37.8% more than option 1 and 62.1% more than actual rolling mill. Conclusions. The calculation results have shown the advantages of changing the available two high rolling mills into the four high rolling mills. The proposed four high rolling mills options is comparison to calculated and available two high rolling mills has the following advantages. More permissible rolling force and more efficient applying of it, which is assured by less working rolls diameters. The possibility to produce a thinner product mix for fewer passes, more maximum and average engineering strain, superior mechanical properties and quality in the final steel rolling products, reducing energy consumption per tons of steel due to more efficient rolling force application and fewer passes. Thank you for your attention.
stability of structural elements of machines in the form of circular arches. Introduction of and Mayer challenges. The article presents solution to differential equation of circular arches. Fundamental functions and their calculation are constructed. To increase the characteristics of strength and rigidity, rod structures of mechanical engineering objects often have large ratios of the moment of inertia of the sections. In the case, the objects meet the standards of strength and rigidity, but this is a danger of loss of stability of the flat bending form. After losing stability, the rod experiences two bends and twists. Large movements of sections often lead to various accidents. Note that the difficulty of avoiding the described phenomena is relevant. The article presents solution to differential equation and of circular arches. Fundamental functions and their calculations are constructed. Aim and research tasks. The purpose of the article is to construct mathematical models of the stress-strain state of the structure of round arches. The paper presents solution to differential equation of circular arches. Fundamental functions and their calculations are constructed. A theory of the stress-strain state of round arches has been proposed and implemented. Tangential and normal stresses, normal forces, shear forces, bending moments, and corresponding deformations are determined. Research methodology. The system of equations proposed by Professor Vlasov for calculating stability in the case of the flat bending shape of a round rod whose cross sections has two-dimensional axes or more can be reduced to the form on the equation 1. Also, you can see this equation on the slide. Also, in the figure 1, you can see calculation diagram of the stability of a rod bent around a circle. Note that in system 1 there are variable coefficients bending moments. Given that in the general case this is some set of simple functions, then the difficulty that will have to be faced when integrated the system 1 become obvious. The task can be significantly simplified if you use the numerical analytical version of the boundary element method. In the presented method, you need to have solution to the Cauchy problem for equation 1, and the coefficients must be constant. Let us describe the integration algorithm for a simplified form of the system of equation. The initial parameters of constraint torsions and bending in the horizontal plane will be as follows, like equation you can see in the picture. Results. The presented outgoing parameters as well as the system of equation 1 from the Cauchy problem of stability of the bending plane of the shape of a round rod. In order to form fundamental solution in the Cauchy problem, a number of transformations need to be made. From the second equation of system 1, it follows that mz will be constant. Having integrated this expression twice, we obtain the necessary relationship between the displacement during bending and the twist angle, as you can see it in equation 3. In this case, the integration constants are equal equation 4. If the substituted from 2 into the first equation of system 1, then we get the resolution of the differential stability equation of the flat shape of the bending of circular rod as equation 5 and 6. The presented equation 5 is a homogeneous and linear differential equation. The equation has constant coefficients of 6 orders. The solution to the equation can be obtained using the standard scheme. The characteristic equation for equation 5 has the form 7. Its root has various types. Let's consider the two most important combinations of roots. Its roots has various types. Let's consider the two most important combinations of roots. The first case, t1 and t2, real multiplies, how you can see in equation 8. The general solution, equation 5, will be written in the form what you can see in equation 9 and 10. By differentiating expression 9 5 times, taking into the account the relationship between the initial parameters and expression 3, it is possible to compile a system of linear algebra equations for integration constants C1 and C2, where the elements of the matrix of coefficients have the form what you can see on the equation 11. Note that 15 is the defining equation of the boundary element methods for the boundary value problems of plane bending stability of various structures in the form of arches, rings, semirings, and combined survilinear systems. Second case, real multiplies are imaginary roots. If mz constant z for round rods, this is a rare case and it's possible only with hanged support and loading with concentrated bending moments equivalent to each other. The equation 15 can be applied to the entire structure following the algorithm of the boundary element method. If mz is some functions of angular coordinate alpha for round roots, this is most common case. It is necessary to have an analytical expression for the functions mz. The easiest way is to construct the functions using the boundary element method algorithm, which describes the procedure for calculating the functions from existing slots. Next, the circular edge is divided into n parts. For each part, the value of the bending moment mz is calculated using a no expression so that the area of the step figure is equal to the area of the real diagram mz. When the condition is met, then n more than 30 gives almost accurate results for critical. Conclusions. The article proposed and implements a theory of the stress-strain state of round arches. Tangentials and normal stresses, normal forces, shear forces, bending moments, and corresponding deformations are determined. The material presented demonstrated that using the algorithm of numerical analytical versions of the boundary element method, it is possible to construct resolving equation for problems of stability of the flat bending shape of round rods, which are used as structural elements in mechanical engineering and the automotive industry. The presented equation can be used to solve scientific and practical problem of stability of mechanical engineering, structural containing roots outlined in a circular arch. As a result of the work carried out, the main functions of the differential equations of circular arches were constructed. This allows you to analyze circular arches and construct their stress-strain state. The use of the result obtained will make it possible to further develop the theory of the stress-strain state of structures made of curved rods and arches. This will allow you to obtain accurate results of calculation of load-bearing elements of mechanical engineering and automotive structures. Thank you for your attention.
Method for vibrations of deformations and stress under natural vibrations.
Introduction and major challenges. A method based on the application of discrete matter and semiconductor strain gauges is widely used to measure deformation and stress during field tests and various machine, vehicle structures, and other products. A feature of testing complex products is presence of a large number of strain gauge points. Therefore, of this purpose, multi-channel strain gauges and an information measuring system for strength tests are used. It should be noted that carrying out practical calculation to optimize the parameters of complex loaded parts requires a number of different algorithms. In those tasks where the existence of many local solutions is assumed, it's possible to use various combinations of calculations methods to find the global minimum of the functional. The expediency of using such combination is dictated by the nonlinearity of the problem to be solved. Penalty function method is one of the most straightforward methods of handling constraints. It's worked by penalizing the infeasible candidate solution and transforming the constrained optimization problems to their unconstrained counterparts. 1. In the use of the multi-channel synchronized dynamic strain gauges for monitoring the position of the natural axis of pre-stressed concert box beams was studied. Multi-channel synchronized dynamic load cells have been developed using edge computing to significantly reduce the emotion of data transmitted from one-side sensor nodes. In boundary computing, only the dynamic strength response caused by the maximum load of the vehicle in each minute is transmitted. This approach significantly increased the efficiency of monitoring and allows for the implementation of non-computer monitoring system on-site. Aim and result task. The goal of the work to develop a technique for measuring deformation and stress in complex loaded parts of cars and airplanes based on the method of penalty functions. In the presence of matching signals from measuring transducers, construct an algorithm for selecting the median to implement the voting principle. Construct a median selection algorithm to clarify information about errors. Research methodology. The simplest method of penalty functions is as follows. A sequence of points x is constructed that satisfies the equalities. 1. Magnitudes can be interpreted as relative penalties per unit violation of the constraints is a barrier functions. When minimized this penalty per deviation of the value, the allowed boundary of the area in the both directions, both plus and in minus. All restriction solution accuracy and the procedure for calculating the functionals are used here f, x, r. Using the proposed method of finding optimal parameters of complex loaded parts can be carried out in 4 stages. Stage 1 call the routine to calculate the penalty functions. Stage 2 start the iterative process. Stage 3 solve linear equation. Step 4 check the constraints condition. For the calculation of the amplitude frequency characteristic, an idealized rod is adopted, taking into account its microprofile consisting of sinusoidal waves, and it's also adopted that the coefficient of distribution of the spring masses is 1. You can see the same equations in 2, 3, and 4. The phase angle is calculated by the formula 5. And also this equation can be written like formula 6, 7, and 8. At the same time, the simplest task is to determine the stress in an axially stressed elements of research objects where the dependence of the normal stress on the measured normal strains described by Hooke's law, where the E is models of elasticity of the material and investigated element of the object. It is known that the generalized Hooke's law is used to find stresses based on the results of deformation measurements in loaded and deformed elements which in the principal axis of the strings had the form 10. The main stresses when the main deformation changes have the form 11. If the isomer, the arbitrary axis x and y are main axes of the strain tensors, and there is an analogy between the theories of stresses and strains, then to determine the strains on inclined platforms, you can see the relation 20, 13 and 14. We obtain the radio for the main deformation in equation 15 and 16. This is the determination of the directions of the main axis of the strain tensors, the main strains, and then the main stresses based on the results of the strain measurement is performed using a tensor rosette. As a result of its solution, we obtain the radio for determining the directions of the main axis of the strain tensors and the radio of the main strains, like in equation 17. Research shows that relation 15 and 17 are not equivalent. However, the definition of main deformation according to 15 and 17 raises doubts about the correctness of the solution problem. Note that 20 is taken from the condition of complete analogy between stress and strain theories. For the axial load of the element of the research object, it takes form 18. However, the stress tensor of the unaxial load as the element can be represented by the relation 21. In the Bexley load element of the research object, the geometry models of the stress-strain surfaces represented the sums and the stress and strain surface models of unaxial loaded. It was established that the stress and accompanying strain are formed in directions of the main axis of the strain tensors, like in equations 23 and formula 24 and 25. Results. Directions for the development and creation of control system using strain-sensitive elements and strain gauges based on semiconductor materials with improved metrological characteristics are shown. The influence of deformation and the main parameters of structure made on different semiconductors has been studied, and the possibilities of their use and as a strain gauge transducer have been identified. Based on the research results of the mathematical model, a methodology for the development of semiconductor strain gauge transducers has been created, which allows one to predict meteorological characteristics at the design stage. This, according to the results obtained, it is possible to develop a semiconductor strain gauge transducer containing a dielectric layer of silicon dioxide on the surface of an N-type silicon single crystal, as well as an insulated electrode, which makes it possible to increase the sensitivity and accuracy of determining the parameters of materials and products. Considering that the measurement accuracy of scaling primary measuring transducers can be increased due to the compensation of systematic errors, the procedure of which is carried out using corrections. It has been established that method based on the conversion of elastic deformations into an electrical signal are currently most widespread. It should be noted that processing signal from measuring transducers using an optimal linear algorithm. In analog interface for remote measurement using resistive strain gauge, its proposed characteristic in that power source is made in the form of direct current source without galvanic isolation, containing a series connected measuring circuits, which includes its strain gauge and the input of which is connected to the power source, a measuring amplifier made on operational amplifiers connected in a two-stage circuit. Conclusions. This is the presence of matching signals from the measuring transducers, the median selection algorithm implemented the voting principle. In addition, the median selection algorithm makes it possible to create a reliable sensor or physical quantity in which the signals failed by the measuring transducers are automatically turned off. It follows that the median selection algorithms are advantageous to use in cases where information about the errors of measuring transducers is either absent or unreliable. High efficiency in estimation using the median selection algorithm is achieved due to the adaptive properties, where the influence of high-level errors in the measuring transducers is sharply limited. Thank you for your attention.
Good day, dear colleagues. My name is Nina Savchenko and I'm from National Aerospace University. I'm glad to present to you our research on the topic Dynamics of Nonlinear Vibration Isolator Parametric Analysis. The task of suppression unwanted vibrations has been one of the most pressing tasks of modern technology for many decades. Increasing demands on the accuracy and efficiency of various mechanisms, instruments, and measuring devices pose new challenges to engineers and researchers. External periodic influence, even of very small amplitude, may cause the disruption of the normal functioning of the system, which leads to unnecessary wear or breakdown of equipment. Among various means of counteracting such vibrations, passive vibration isolator devices occupy an important place. They have a relatively simple design, are not very expensive, and are rather effective in operation. However, a comprehensive study of the dynamics of the system is not a simple task. Since the corresponding model is multi-parameter and the use of numerical methods doesn't always provide all the answers described. Therefore, an important part of the work when developing such system is the parametric analysis of the dynamics of the system under study. That's why our main aim and research tasks are to derive an analytical procedure for obtaining basic relationships for analyzing the dynamics of an isolator depending on the relationships between the attenuation coefficient and nonlinear components of the elastic force. Next, under conditions of a known range of possible external excitation frequencies, present a numerical analytical scheme for the optimal selections of the parameters of an isolating device. The last task is to compare the proposed approach with two types of isolators described in the literature. Let's go to the research methodology. Consider the following model equation 1, which describes the motion of a mass under the action of nonlinear restoring force, viscous friction force, and external harmonic excitation. Introducing the dimensionless parameters and variables using formulas 2, we rewrite equation 1 in the form 3. We will look for a solution of this equation in the form at the bottom of the screen. Using the harmonic balance method and limiting ourselves to first-order harmonics, we have equalities 4, 5, and 6. Take into account the main trigonometric identity. The last two equalities lead to condition 7. As one can see from the frequency amplitude curve, smooth down as parameter K2 decreases when the spring becomes more softening. Also, the magnitude of the responses decreases significantly. Equality 4 and 7 can be used to find the resonance value of critical value of omega, as well as the corresponding values of y max and y0. In fact, corresponding the latter function of the argument omega, we have equality 8. Generally, since the system of equality 4 and 7 contains 6 unknown quantities, in the general case, it's too complex for analysis. However, taking into account that for applied tasks, the value of A can vary in the range of 10 in minus 1 power for low frequency excitation to 10 in minus 3 power, where values of kappa 1 and kappa 2 are expected to be small enough, which will allow us to use the asymptotic representation. Therefore, the choice of small parameters depends quite strongly on the characteristics of a particular mechanical system, in the same way as it done for the dimensionless response y of the system. One can analyze the behavior of displacement transmissibility. Taking into account that maximum of y can be written in the form that presented on the screen, we have the expression 9 for displacement transmissibility. Let's consider mechanical system, which you can see in figure 2. The system contains of a vertical spring with viscous damping and a pair of oblique spring. The dependence of vertical applied force F on displacement x is presented on the screen. The quasi-zero stiffness idea is to achieve the nullifying of a linear component in the resulting elastic force by choosing the ratio between the linear and cubic components of the stiffness of inclined springs. We have condition 12, and the expression of the elastic force takes the form 13. Approximation of the function f by third-order polynomial is presented in figure 3. Thus, we arrive the equation 3 with linear and quadratic terms of elastic force. Relation 7 and 9 takes the form 14 and 15, which are easy to use to find optimal values of the mechanical parameters of the model under consideration. In particular, to achieve the minimum value of displacement transmissibility, considering the parameters kappa 2 and zeta given, we can write equalities 16, from which we find the value of r and omega with numerical values for m, c, and a, respectively. We can find critical value of omega and y0. You can see that in figure 4. And corresponding frequency amplitude dependence are presented in figure 5. In Zhang work, a negative stiffness magnetic spring was proposed to improve vibration isolation under low frequency excitation to reduce the resonant frequency of the linear isolation. The negative stiffness magnetic spring consisting of a pair of coaxial annual permanent magnets was mounted parallel to the mechanical spring to counteract its positive stiffness. Taking into account the smallness of parameter kappa 2, we can obtain an asymptotic expansion for r as a function of parameters zeta and omega 17. It's easy to see that near the resonant frequency, the value of damping coefficient plays a significant role. Considering such a small value of kappa 2 for the chosen model, it's more profitable to increase the values of C. In fact, according to Zheng work, an increase of negative stiffness magnetic springs power reduces the maximum value of displacement transmissibility by 15–20%, while at the same time increase in the value of coefficient C from 5 to 10 gives a twofold reduction. It's presented in the figure 6. The result obtained allow us to derive the analytical procedure for obtaining basic relationships for analyzing the dynamics of an isolator depending on the relationships between the damping coefficient and the nonlinear components of the elastic force. Under the conditions of a known range of possible external excitation frequencies and numerical analytical scheme for the optimal selections of isolation device parameters is presented. A comparison of the proposed approach with two types of isolator described in the literature shows its effectiveness. Thank you for your attention.
Okay, thank you very much. Thank you very much for presentation, for technical support for this. And now I open discussion for topic. Colleagues, can you some question for our participant? Maybe no question in this time. Or Vitaly?
No questions from me, and there is no questions in the chat. So if you have any questions, please ask them to participants one by one. Okay, dear participants, maybe I will ask a question. Konstantin, thank you very much for your presentation. Are you with us?
Yeah. Hello, I'm here. Thank you.
Okay, thank you very much for your participation and presentation. I have a question regarding your presentation, simulation of the shaft surface strengthening as a result of discrete electromechanical processing. My question regarding is the practical implementation of the results. What are the prospects of this technology methods for implementation?
Okay, thank you for your question. So first of all, the idea was to apply to develop the applied methods of the strengthening of the upper coat of the shafts in the gearboxes, etc. So the practical part will be to investigate the optimization methods and to perform the optimization of the strength of the shaft surface and make it more durable. And the future research will be dedicated actually to the simulation in the same ANSYS by using the suggested methodology and using different types of materials. For example, by using the Granta pack, which is widely known in the ANSYS, we can use different kinds of steels and use different stress-strain curves, which are upon the yield point of the material, and simulate with different kinds of those stress-strain curves I mean, bilinear, isotropic hardening, or non-linear at all. And the future of this methodology, suggested methodology, is actually to perform such simulation tests and to find the sequences between them and to suggest the optimal solution. So I hope this explanation will clarify your question, however, particularly.
Thank you very much for expanded answer. I am satisfied, fully satisfied. Thank you very much.
Thank you very much, Vitaly.
Yeah, we have a question from Volodymyr.
Volodymyr is
No, sorry, I have questions for the third speaker. I'm
Okay.
wait, the third report.
Okay. So let's move to the next presentation. It was presented by research team from Odessa. I'm not sure that participants now in the chat. Are there any authors of this presentation now? Please let me know. Let's move to the next presentation.
Oh, it's my
Okay,
questions. Sorry, Pani Elona, why is it proposed to use the rotor balancing using passive automatic liquid type of balancing, ABD, and what are the pros and cons of this solution compared to the other methods of balancing rotary machines?
Thank you for your question. The problem of balancing machine rotor is important. Automatic balancing is effective for rotor with variable imbalance and has a number of advantages. You can see this presentation. The results of this study is an assessment of the angular velocity of the beginning of the balancing process in the subcritical range. This will allow in subsequent studies to justify the operation of a liquid auto balancer for a rotor with an arbitrary angle of inclination of the rotor axis. And this will make it possible to expand the areas of use of liquid auto balancing.
Thank you. And can I ask a second group of questions? What is the specific practical significance of the proposed paper? What scientific result can be used to improve the balancing techniques, equipment for balancing?
For mass produced machines, especially household ones, it is of great importance to reduce and cost of ABD. Simplicity, the design and facility maintains, as well as the possibility of repeat use without reconfiguration the recurrence for balancing accuracy are usually reduced. For this class of machine for non-stop balancing and the operation conditions of the machine's rotor, it is advisable to use liquid type passive ABDs when
team for these answers.
Thank you very much.
Thank you.
Next presentation is method of accelerated tested of axial piston pumps. Yeah. Maybe I have one question. What is potential using in real practice? Your result from this article.
I'm afraid that there is no speaker. Am I wrong? Please correct me.
Oh, okay.
Okay. Anyway, the question was announced, so the participants can rethink about it and see it later. So,
okay.
Next presentation.
Tak, next presentation is Mr. Volodymyr Kuchar.
Yes, I'm here.
Professor Kuchar is here. He is open for questions.
I have a question with Mr. Kuchar.
Okay.
According to the diagram on slide 6, there are two heating furnaces next to each other. Please explain why.
It's about the furnaces that, of course, sorry, it's just the way is shown. The schematic is confusing. In the rolling shop, the line 1 and line 2 are parallel, and after the passing through the line of the plate mill, the metal product can be either finished to feedstock or the next line with the stackle mill. In other words, after passing the plate mill, the cargo flow is reversed.
Thank you. Thank you.
I don't have questions. Maybe a session chair.
Okay. Some question for this contribution. If not, we can continue to next presentation. Okay. This presentation is stability of assured structural elements of machines. Mr. Alexander.
А в Одесі повітряна тривога. У нас доповідачі у викриття пішли. Я можу відповісти, але ж українською мовою.
Okay, we are thinking that safety is the most important at this moment. So, Alexander, please go to the shelter and we will skip a discussion about your presentation. Alexander just informed that the air alarm was announced in Odessa, so the first recommendation is go to the bomb shelter to avoid any situation. So, I suggest to move to the last presentation in this session to speaker Nina Savchenko.
Okay.
Or maybe, I'm sorry, maybe the authors from this presentation, methods for variation of deformations and stress under natural vibrations.
Це теж Одеса, Це от Вадим Хамра, він нас добре розуміє українською, але ж він в укриття пішов. Та й інші теж в небезпечні місця пішли. Бо зараз буде працювати, буде громко.
Thank you for informing us. Okay, next presentation is from Nadia Savchenko and Volodymyr Puzyryov, Natalia Loseva. It's an international team represented by scientists who represents Spanish institution and Ukrainian. Any other questions to our speakers?
Yes. Is some question for this contribution?
There is no question from me.
Okay.
Okay, so if no questions, please sum up.
Okay. Thank you very much. Thank you very much for your presentation and for discussion. Now we continue to next section. I think start Vitaly in 12 or 11 o'clock. Yeah. Okay. Thank you very much. I am very happy that I see your faces. And I hope that the next meeting will be face to face, and be healthy and be happy, and thank you very much, and bye bye.
Thank you very much.
Dear colleagues, this is Odessa, Ukraine. My name is Vasily Larshin. I am working in Odessa Polytechnic University. We are beginning session number 7. The name of the section is Process Engineering and Professional Development. We have seven reports, 7 presentations. The first presentation, the topic, the following. The Camber-line optimization procedure for mixed inflow tubing router. Authors or speakers Mohamed Emin, Chelabi, Евгений Босава, Сергей Добротворский, Dmitro Trubin, and Alexander Harchenko. This is first presentation. Next, second presentation. Modeling of gas dynamic processes of wave low temperature heat generators, dynamic gas distribution. Speaker is Dmitro Demertsov. Number three. The topic is use of vibration machine to obtain ammonia water for plant feeding. Speakers Anatoly Hordeyev, Igor Sidorenko, Alexei Matveyev, Victor Kurgan, and Yuri Yeputatov. It was set presentation. The following fourth presentation is the topic is the use of vibromechanical intensification to optimize heat exchange in transport and technological machines. Leonid Nikolaevich. Technological machines. Authors or speakers. Igor Palomarchuk, Mikhailo Mushtruk, Yuri Boyko, Igor Standnik and Andrei Derkach. Presentation number 5. The topic. Professional situations modeling for bachelors in information technology training. Speakers. Sergey Kuliyeshov, Mikhailo Alamshoeva, and Anna Ostapenko. The following presentation, number 6, diagnostic assessment of professional competence levels of engineering teachers. Speakers, Petro Luzan, Olena Titova, Irina Mosia, Tatiana Pashchenko, and Tatiana Ischenko. It was presentation number 6. And the last presentation, number 7, the topic is quality management of training of engineering personnel in the conditions of developing the management competence. Speakers, Viktor Negaev, Natalia Moiseyeva, Victoria Novikova, Tatiana Mitiashkina, and Sergey Chervony. You had the topics of 7 presentation. Let's begin the presentation. presentation number 1. Yes? Presentation has started in YouTube. This is the beginning. Yes? Right on.
My name is Chelabi Mohammed Amin, and I have the privilege of presenting a detailed analysis of the article titled The Camber Line Optimization Procedure for Mixed Inflow Turbine Rotor. This presentation aims to highlight the main issues addressed concerning the optimization of blade geometry, examine the key arguments developed by the author, and discuss the implications of these points in the current context. I am delighted to share this in-depth reflection with you and hope it will spark enriching discussions and new perspectives. Aim and research tasks. The rotor type A camber line optimization procedure of mixed inflow turbine was the subject of this study at 2 steps. In the first step, the trailing edge optimization was verified in 3 parts, by using a mathematical model based on the Bezier polynomial in 4th degree. This verification is constructed by varying of the point's position's coefficients. Of course, the same leading edge was kept, eliminating its effect on the mixed inflow turbine rotor performances. At the second step is the correction of the leading edge curve by varying the reference camber angle and keeping the same trailing edge. The angle values studied were limited to ensure the camber line continuity. All geometrical parameters were constant to keep the same rotor casing. The aim of this research is to enhance the efficiency and performance of mixed flow turbines, crucial for improving turbocharger efficiency in automotive applications overall. Introduction and major challenges. Turbocharging a combustion engine enhances its power by increasing the air-fuel mixture delivered to the combustion chamber. The turbocharger uses exhaust gases to spin a turbine, which compresses incoming air and pushes it into the engine. This process increases the amount of oxygen available for combustion, resulting in stronger piston explosions and more engine power. However, turbochargers depend on exhaust gases to operate, leading to reduced performance at low engine speeds when exhaust flow is less. Typically, mixed and radial inflow turbines are preferred over axial inflow turbines due to their superior performance. Research methodology. The blade geometry is defined by the hub and shroud projection on a meridional plane, see Figure 1, and the camber line, see Figure 2. The task of defining analytically the blade geometry is carried out by using Bezier polynomials. Since the rotor will be included in the same casing, all the geometric parameters of the meridian plane have been kept constant. When B2 is the blade height at rotor inlet, D2 is the mean diameter at rotor inlet, R0h is the radius at the tip rotor inlet, x1 is the rotor length, D3h is the exducer hub diameter, D3 is the exducer root mean square diameter, D3s is the exducer tip diameter, and delta 2 is the cone angle at rotor inlet. Initial rotor shape and boundary conditions. For the numerical model validation following a mesh-independent study, a rotor of type A was selected as the reference prototype. The geometric parameters of this rotor are detailed in Table 1, as outlined in Chalabi's previous works. The calculation field is an interblade channel, the fluid is an ideal gas, with the stationary mode, its speed is equal to 98,000 rpm, and the K3 was used as a turbulence model. The inlet mode is subsonic, where the totals pressure and temperature are, respectively, equal to 2.91 billion Argentine pesos, 920 K with an absolute flow angle of -13. At the exit, the static pressure is equal to 1 bar, the heat transfer mode of the walls is adiabatic, the blade, INTR reduce and extrados, was considered a dynamic wall, the shroud and the hub as the static wall with the periodicity condition for periodic walls, and the CFX.15 was used as a simulation code. The method presented previously has been devised and programmed for the design and optimized the blade shape to obtain the highest performance. In the first step, the trailing edge optimization was checked in 3 parts, by varying the position of the interior points, P1, P2, and Pb, by the position coefficients changing of the polygon points defining the Bezier curve. The method enables the geometry of the blade to be modified. The design process, all geometries how has obtained are presented in the figures 3, 4, 5, 6, 7 and 8. It was noted that the position coefficients of the points P1 and Pb have a great impact on the three-dimensional blade shape, this effect due to the large distances between P0, PC and PC, P3, while the other coefficient of point P2 has a weaker impact because it is dependent on point Pb. The leading edge curve correction was carried out by varying the reference camber angle and keeping the same trailing edge. The choice of reference angle values was well determined to ensure the camber line continuity. It was noticed that the aerodynamic rotor shape is changed completely in the front blade part, see Fig 910. Results. The shape of the rotor blades plays a crucial role in determining the performance of a turbine. To illustrate this impact, simulation results have been gathered for 2 different rotor blade configurations, with a focus on 3 key performance metrics: output work, power, and total to static isentropic efficiency. These results are analyzed at the turbine's full rotational speed, providing a comprehensive comparison between the 2 blade shapes. By examining these performance indicators, we can better understand how variations in rotor blade design affect turbine efficiency and overall effectiveness. The trailing edge optimization. Concerning the first case, which represents the trailing edge optimization in 3 parts by varying the position coefficients of P1, P2, Pb, the graphical analysis of the rotor performance showed that output work, see Figure 11, power, see Figure 12, and efficiency, see Figure 13, are very sensitive. The position of point Pb has the great impact and the point P1 has the lowest effect. The output work, power, and efficiency were increased by increasing the position coefficients up to optimal values which correspond to the referential blade, then they were reduced. This performance evolution due to changes in the three-dimensionality of the blade where the blade surface increases, which will widen the exchange surface between the fluid and the rotor, which signifies the increase in work, and the blade curvature adapts with the flow direction, which reduces losses by internal leakage, which proves the increase in efficiency. The power graph evolution is identical to the work exchanged because of the equality of mass flow in these cases studied. The decrease in performance after the optimal point is due to the increase in frictional forces, as well as the new curvature does not adapt with the flow. New approach. The camber line, which was presented in Figure 2, is composed of a leading edge which starts from point A to point P0 and a trailing edge which begins by point P0 to P3. The leading edge curvature is calculated by the following relationship 1. The trailing edge was calculated using a mathematical model based on the Bezier polynomial in 4th degree with the following relationships 2 and 3, where the items of 0 and 3 are defined as follows. Where x is the axial polar variable, theta is the camber line angle, r is the radial polar variable, u is a variable between 0 and 1. Alpha is the deviation angle. The leading edge optimization. For the second case, which corresponds to the leading edge optimization, it has been noticed that the rotor performances, see Figure 14-15-16, are directly proportional to the referential camber angle. These results can be justified by reduced blade convexity, see Figure 9-10, and the flow becomes more adapted with the geometry of the rotor. Acknowledgement. I wish to express my sincere gratitude to my fellow researchers for their invaluable collaboration and commitment throughout the writing of this paper. Their expertise, deep insights, and constant support have been essential to the completion of this work, greatly enriching our analyses and conclusions. I would also like to extend my warm thanks to the organizers and leaders of the InterPartner-2024 conference for their exemplary organization and for providing the opportunity to present our research. Their support and guidance have played a crucial role in the dissemination and discussion of our findings. Lastly, a big thank you to everyone who contributed to the realization of this project, whether through direct or indirect support. Their help has been invaluable. Conclusions. Advances in the design and manufacture of mixed inflow rotor blades used in turbocharging of internal combustion engines allow manufacturers to increase both the machine's performance and efficiency by operating them in increasingly high rotational speed ranges. However, the increasingly significant forces generated place strong demands on the overall dynamic behavior of the machine, and the geometries often become too complicated for manufacturers to construct. The presentation of the camber line optimization procedure for mixed inflow turbine rotor type A was the objective of this article. Presenting the camber line optimization procedure for A-type mixed flow turbine rotor was the objective of this paper. To improve its performance, this optimization is allowed to correct the blade curvature while keeping the same diameters and rotor angles. This procedure was done in 2 stages. The first was the trailing edge optimization in 3 parts by varying the position coefficients using a mathematical model based on the 4th-degree Bezier polynomial. It was found that the trailing edge of the prototype blade is optimal. The second step was the leading edge optimization while keeping the same trailing edge profile. This correction was made by varying the blade referential angle. This correction revealed that the optimal profile has a large referential angle, which makes it possible to reduce the convexity of the blade. Thank you for your attention.
The use of vibromechanical intensification to optimize heat exchange in transport and technological machines. A study by Igor Polomarchuk, Mikhailo Mushtruk, Igor Stadnik, Andriy Derkach, and Yuri Boyko. Coming from National University of Life and Environmental Sciences of Ukraine, from Ternopil Ivan Poluy National Technical University and National University of Food Technology. Creation of favorable conditions for intensification of the production process and application of effective methods of influence on its object, continuous implementation of the technological movement, the reduction and elimination of the general use of unproductive labor, in particular in the implementation of the support operations, control of the dynamic state of the system in which the technological action takes place, the multifunctionality of the technological process and the harmonious combination of its main structural components make up basically the trends in the development of the technical process in the fields of production and processing of agricultural and industrial products. With modern technological and constructive properties of conveyor machines open up new opportunities for their implementation and development in many areas. This makes this research extremely relevant. The purpose of this scientific study is to develop the energy-efficient and reliable technological schemes for vibrating conveyor heat exchange processing of bulk products. This includes the analysis of the main characteristics, structural elements, and modern trends in the development of vibrating transport and technological machines, as well as the determination of kinematic and power parameters of systems that do not use vibration. In addition, it is important to substantiate effective modes of promotion of raw materials in the processing area. The research aim is the development and implementation of methods of vibromechanical intensification to optimize heat exchange in transport and technological machines, which will allow to increase the efficiency of their work and reduce energy costs. Among research tasks, there are the conduction of an analysis of existing methods of heat exchange intensification and determining of their advantages and disadvantages, the determination of the influence of vibromechanical processes on heat exchange in transport and technological machines, the development of a mathematical model describing the process of vibromechanical intensification of heat exchange, and also this research aims to experimentally investigate the effectiveness of vibromechanical intensification in conditions close to real operating ones. And finally, this research also tries to evaluate the economic effect of the implementation of the developed methodology in the industrial conditions. For theoretical investigations, contemporary principles of solid mechanics, including the mechanics of deformable bodies, solid and fluid media, elasticity theory, and vibration processing and transport, are employed. And in the course of experimental studies, German Robotron equipment was utilized to access the kinematic parameters of vibration. Electromechanical systems facilitated gradual variations in the rotational frequency of the vibration exciter's drive shaft. And amplitude frequency characteristics, vibration velocity, and acceleration of the vibration exciter's components were recorded using the oscillograms from the Robotron apparatus, and the advancement speed of products was measured with an accelerometer integrated with a computer processor. Concurrently, adjustments to the rotational frequency of the vibration drive shaft were executed via laboratory autotransformer AOSN 20-22075, manufactured in Poltava, Ukraine. An electronic wattmeter EMF1, also from Poltava, Ukraine, was employed to access the energy consumption from the power grid during the research. Simultaneously, the positions of the imbalances are altered about each other, either symmetrically or asymmetrically, concerning the vertical axis of the support roller, as well as about the vertical axis of the vibrating machine. To assess the functionality of the studied oscillating system, 3 primary groups of parameters are employed, facilitating the optimization of infrared drying modes via a vibration wave driver: amplitude frequency characteristics, power characteristics, and energy characteristics. The amplitude frequency characteristics allow for the evaluation of the force's depth through oscillating amplitude and intensity, while also identifying resonance peak regions and the operational modes of the machine's actuators. Power parameters assess both the impact on the processed products and the structural elements, and support nodes, thereby influencing the equipment's reliability. And energy characteristics enable a technical and economic evaluation of the system's performance, utilizing parameters such as drive energy consumption and components of the vibration exciter's power balance. The technological impact of vibration can be categorized into 3 primary components: the specific influence on the mass of the products being processed within the working container and on the machine's operational parts; secondly, the intentional alteration of the system's technological resistance; and lastly, the functional universalization achieved through the application of vibromechanical elements, as illustrated comprehensively in Figure 1. The integration of the aforementioned parameters enables the generation of diverse vibration pulses, captured in Figure 2, characterized by variations in magnitude, direction, nature of action, and depth of propagation within a plane or space. This flexibility facilitates the creation of complex motion trajectories for the technological masses being processed. Such fiber effects relate to loose, raw materials. Variations in the magnitude and direction of these vibration excitation characteristics make it possible to realize the force moment and combine non-vibrationally of the vibrating system, which makes it possible to predict the features of the movement of products in the working area. Based on the graph-analytical analysis of the values and the diagrams of these parameters for all the presented schemes of non-equilibrium, it turned out that the combined action of forces and moments on the right or left dynamic screw is effective in achieving the desired spiral trajectory of the flow of bulk masses, as pictured in Figure 3. To experimentally assess the transport movement parameters of loose, rapeseed, and soybean masses during their heat and mass exchange dehumidification, a specifically designed vibration wave infrared dryer was employed. This apparatus exerts a multifaceted vibrational influence on the technological parameters of heat and mass exchange. It loosens the bulk material, thereby enhancing the heat exchange surface area. It facilitates continuous mixing and renewal of the product's surface layers, which effectively lowers the specific thermal load from infrared radiation, and it generates standing or traveling waves on the supporting transport surface, enabling precise guidance of products along controlled trajectories. Using advanced measurement instrumentation, keys, kinematic, and energy characteristics of the oscillating system were analyzed across varying angles of imbalance orientation, and the inertial force of the unbalanced components was observed to decrease from its maximum value to 0 at the angle varied from 0 to p. The variation of imbalance positions facilitating the generation of graphical dependencies of vibration parameters is illustrated at Figures 4 and 5. In assessing the deviation between theoretical and experimental studies, the evaluation criteria include energy and kinematic characteristics of the process under investigation. The kinematic characteristic utilized in is the velocity of the processed products, which is directly proportional to the mass productivity of the dryer. For the energy parameter, the power consumption required for infrared drying within the moving bed of raw materials is considered. These evaluation criteria are critical in determining the technical and economic efficiency of the studied processes and their operational environment. The characteristics are defined for two methods of implementing infrared drying within the moving product layer as depicted on Figure 6. Figure 7 presented at the slide is a comparative analysis of the theoretical and experimental studies regarding kinematic characteristics reveals the following. And Figure 8 presented a comparative analysis of theoretical and experimental studies on the energy characteristics of the process. According to those figures, vibration effectively reduces the effective coefficient of friction, resulting in more uniform processing of products. Experimental data support these hypotheses. As illustrated in previously shown Figure 4, varying the positions of unbalanced elements enables the adjustment of vibration parameters, which contributes to a reduction in the friction coefficient. These technological innovations can enhance the processing uniformity and decrease the duration of technological actions. Since the vibrational effect enhances heat and mass exchange process by increasing the contact area, it results in the indications that we received through this study, and they indicate that vibration facilitates in continuous mixing and renewal of the surface layers of products, thereby augmenting the contact area available for heat and mass exchange. As depicted in Figure 5, this improvement results in a reduction of the specific thermal load from infrared radiation and lowers energy consumption for drying. Analysis of conveyor vibrating machines shows the flexible element of these units performs several important technological functions. It transports the working medium, increases the efficiency of heat and mass exchange, renews the contact area of the processed products, removes them from the processing zone, and creates a movable bottom of the working container, or even all the walls of the working chamber. A comparative analysis of the kinematic and energy parameters of transportation of bulk products using a vibrating wave conveyor for IR drying and traditional belt conveyor revealed an impressive result. The speed of movement increases almost twice, and the energy consumption increases by 1.6 times. The application of a combined non-balancing mechanism in the vibrating system influenced by perturbing power parameters along the right or left dynamic screw enables wave support of bulk technological mass without the need for additional mechanical devices. This approach enhances the speed of product within the working zone by 29% compared to moment imbalance, and by 46% compared to power imbalance, with corresponding increases in energy consumption per drive of 8 and 19% respectively. We thank you very much for your attention, and if any further information is required, please refer to the following.
Dear audience, we are glad to discuss the problems of modern training of bachelors in information technology and to introduce you the results of our research on professional situations modeling for bachelors in information technology training. In today's technological world, IT is an integral part of a modern person's life. It is applied in all areas of activity, from personal communication to business, and requires in-depth knowledge and skills in this field. Bachelors in information technology are the future experts in IT, and it is crucial for their professional development that the educational process is embodied in effective and engaging classes. Undergraduate training in IT is the process of teaching students the fundamentals of IT at the undergraduate level. IT students learn the fundamental concepts of programming, database management, networking, cybersecurity, web development, and software engineering. Bachelor's degree programs in IT typically include theoretical and practical classes, as well as internships and project opportunities. Their primary objective is to equip students with the knowledge, skills, and work experience required for a successful career in IT. This presentation aims to highlight the benefits of professional situations modeling for bachelors in information technology training. Our research tasks focus on exploring the effectiveness of this approach in fostering practical skills, critical thinking, and problem-solving abilities. Research tasks are formed to achieve this goal. 1. Analyze the goals determined by the context of professional situations in the IT field. 2. Search for real-life examples of successful practices used by universities and software manufacturers. 3. Analyze and generalize of real-life examples of successful practices used by universities and software manufacturers. Widespread introduction of digital technologies and artificial intelligence to all spheres of life, especially to education, has changed the learning goals, content, teaching technologies, aids, and methods. The interaction between teachers and students has also been transforming. There is plenty of studies dealing with the analysis of digital tools in terms of the educational tasks that could be solved in new ways. On the other hand, scientists are studying and substantiating the skills and competences needed for successful professional activity of different fields in a digital society. Nowadays, the digital competence is becoming the leading one among others such as creativity, problem-solving, leadership, communication, etc. In the first stage, the methodology for studying the professional situation modeling included the analysis of the goals determined by the context of professional situations in the IT field. The most popular methods and tools used at universities were studied. The study was conducted according to the criteria that includes the frequency of educational technology use, the possibility for developing definite professional and personal qualities, and others. The second stage was devoted to the search for real-life examples of successful practices used by universities and software manufacturers. To select successful practices of professional situation modeling in IT training, certain criteria were defined. High rating of the educational institution where the practice was implemented. Accessibility of the practice for students. Clearly expressed universality of the practice, which means the possibility of changing the conditions, scenarios, or venue. The internship should motivate the student to study and research, as well as to be independent in performing their functions and making decisions. The internship should develop soft skills, communication, collaboration, etc. In the third stage, the analysis and generalization of the real-life examples of successful practices used by universities and software manufacturers were carried out according to the learning objectives determined by the context of professional situations in the IT field. The analysis and generalization of real-life examples of successful educational practices involves identifying common elements and principles that contribute to their effectiveness. In accordance with the global rankings of the most esteemed higher education institutions, the majority of the top positions are held by universities in the United States. Consequently, an investigation was conducted into the professional situation modulation methods employed by U.S. universities. American universities use various methods and technologies to modulate educational situations in the field of IT. The most popular ones include virtual laboratories, real-world projects, research and development activities, and simulation games. Modern virtual labs give students the opportunity to learn and experience practical IT concepts. They are accessible because they are web-based and cover a wide range of IT industry topics. Additional benefits of virtual labs include easy tracking of student progress and assessment, experiment visualization, and demonstration of processes in a virtual environment for better understanding. To sum up, virtual labs empower IT students by providing flexible, accessible, and engaging learning experiences. As can be seen from the experience of Stanford University, the use of virtual laboratories is quite widespread, as it provides great opportunities for teaching and has a positive impact on research motivation. A high-quality virtual lab has a great impact on the development of such skills as planning, analysis, critical thinking, etc. Also, this type of laboratory can significantly accelerate research, as students can conduct multiple experiments and get results immediately ASAP. Another popular solution for modeling educational situations in the field of IT is real-world projects. In the course of such events, universities often cooperate with various organizations and institutions. This allows students to use the skills they have acquired in the classroom to solve problems in a real work environment. Real-world projects can significantly enhance the learning experience for students in the context of IT higher education. Thanks to these programs, students have the opportunity to receive practical training in teams led by current practitioners. This helps to enhance their technical competencies and gain a comprehensive understanding of their chosen specialty. As a result, the transition from education to the workforce becomes smoother, while continuously improving the productivity of students as future IT specialists. Project topics can cover a variety of areas and focus on the development of core skills, developing an application to track expenses and income to improve financial literacy, creating a social network platform or an online shop site to improve web development skills. In summary, the integration of live projects into higher education nurtures practical skills, establishes industry connections, and prepares students for the dynamic world of IT. Research and development activities are essential for both professional and personal growth. Therefore, they constitute a significant part of modern curricula in American universities. These activities enhance students' adaptation and decision-making skills, resulting in higher grade point averages for more cooperative groups. Personal traits, qualities, values, and abilities, as well as shared beliefs and motivations, play an important role in research and development activities. A positive social atmosphere within a team allows each member to learn from one another's strengths and share unique experiences. Effective collaboration leads to increased engagement and creativity. Research and development activities are crucial for the professional training of future IT specialists. They significantly influence academic success and personal growth, as well as prepare individuals for teamwork in their future careers. Simulation games are becoming increasingly popular in modern IT higher education. They can be used in various areas of training, such as data analytics, cybersecurity, web and software development. Game scenarios offer interactive experiences and practical skills that can be applied in real-life situations. Simulation games can enhance critical thinking, theory comprehension, and practical skills. They have a positive impact on student motivation, leading to increased knowledge, engagement, and improved ability to solve tasks in the professional sphere. In summary, simulation games are an effective tool for improving learning outcomes and developing necessary skills in the professional training of future IT specialists. Educational situation modeling is a powerful and very popular teaching method at American higher education institutions. It allows educators to create the right conditions for active and productive improvement of knowledge and skills throughout the educational process. Educational situation modeling as a teaching method has been studied and improved by many well-known researchers in the fields of pedagogy, psychology, epistemology, and others in parallel with the development of human society and scientific and technological progress. The main types of simulation of learning situations in American higher education institutions are virtual laboratories, real-world projects, research and development activities, and simulation games. According to the analysis, it has been found that working in virtual laboratories has a positive impact on the development of planning, analysis, experimentation, and critical thinking skills, while also allowing for personalization of the educational process. Real-world projects help to improve social responsibility, independence, creative thinking, problem-solving skills, etc. Research and development activities such as hackathons, discussions, team challenges and competitions are well suited to develop communication and teamwork skills, improve out-of-the-box thinking, practical skills, and professional growth. Simulation games are an excellent tool for engaging students in the educational process, developing practical skills in many professional scenarios, assessing student performance in detail, and constantly increasing motivation to improve themselves by learning from their mistakes. A detailed analysis of the American experience will highlight effective methods and tools for modeling learning situations, structuring classes, setting goals, selecting tasks, and assessing learning outcomes that can be adapted and recommended for implementation. Therefore, our further research is planned to be devoted to the adaptation and integration of the described methods of modeling learning situations to specific learning requirements in order to obtain guaranteed results in the framework of competence-based learning at non-American universities. Thank you for your attention.
Our sincere greetings to all the participants. We're grateful for the opportunity to participate in the conference and discuss the urgent problems of engineering education. This year we are presenting the findings on the problem of the assessment of engineering teachers' professional competence level. Let me start with the introduction and outline the major challenges for the research. At the times of information society, all spheres of life are dynamically developing. The requirements for the quality of engineering education are also changing rapidly, and the teacher is becoming the leader of positive changes. Educational practice convinces a teacher nowadays should be a facilitator who reveals the student's potential and helps the student's personal and professional growth. The main function of an engineering teacher is to convey sophisticated engineering knowledge to students, foster their creativity, teach them to analyze conventional and non-conventional production situations to gain experience in solving problems. For this, the teacher must perfectly possess an engineering specialty, be aware of modern production, and realize the prospects for developing machines and equipment. Local and global challenges, constructive factors, and unlimited possibilities of digital technologies significantly change the tactics and strategy of teaching engineering students. It means engineering teachers should develop their growth mindset and employ a new concept of professional improvement using advanced technologies. These all refer to diagnostics in the educational process, which is a fundamental practical matter that requires high qualifications and responsibility from teachers. The scale of this problem actualizes the search for effective methods and tools for engineering teachers to provide not only the diagnostics of their students' achievements but to perform the teacher's competence diagnostic assessment, which should be considered and realized through the appropriate methodology to ensure the positive dynamics for the professional competence of engineering teachers' development. Moving on now to the aim and research tasks. Since a teacher's professional development is a continuous process, the article aims to substantiate and develop a valid diagnostic tool for assessing the professional competence levels of engineering teachers at any stage of the teacher's professional growth. For that purpose, the following research tasks were set. To substantiate the approach to the assessment of engineering teachers' professional competence levels. To develop a diagnostic tool. To validate the tool during the two-stage experiment. Let's go on with the research methodology. The effectiveness of the teacher's pedagogical activity directly depends on the intellectual potential of the individual, psychological qualities, fundamental professionally important skills and up-to-date skills that form the basis for professionalism and further teachers' professional development. To diagnose and manage the process, it is important to realize the essence and the structure of the phenomenon under study. The professional competence of an engineering teacher at college was considered as an integrative property of an individual with the following structural components. So, we could predict that by evaluating the development of one or another component according to the presented indicators, those characteristics together would determine the nature of changes in the development of the teacher's professional competence. Based on the substantiated indicators, a questionnaire was compiled. The questionnaire offered the respondents to evaluate the development of their knowledge, skills, and other qualities in 15 positions according to a 5-point scale. Motivation and value mean motives, and value orientations to master high professional levels. The cognitive information component includes knowledge in engineering, psychology, teaching methods, etc. The behavior and activity component refers to the abilities and skills to realize the teaching functions. The personal reflection component is connected with self-regulation, and finally, the emotion and volition component considers the ability to control emotional state while teaching, and the purposefulness of teaching actions in the learning environment. The development of structural components of the engineering teacher professional competence can be functionally characterized by the criteria, which are determined by a set of indicators. The suitability of the diagnostic tools was determined through the theoretical validity, which showed the degree of accuracy of the diagnostic technique and the conformity of the results obtained by different methods. For that purpose, a small-scale statistical sample experiment was conducted in the conditions of a separate Ukrainian agricultural and technical college. In the first stage, the respondents, 52 college teachers, carried out a self-assessment for their levels of development of the professional competence components according to the given above diagnostic procedure, research method. In the second stage of the experiment, the levels of development of the components of the respondents' professional competence were determined using expert evaluation when the results of educational, organizational, and scientific activities of the participants of the experiment were being analyzed. The results of the small-scale experiment were statistically processed. The coincidence or difference between the results of the application of research and expert methods was determined. To decide which of the above hypotheses was worth accepting, Pearson's chi-squared statistical test was applied. A full-scale study of the levels of development of the engineering teacher's professional competence, 2023, was provided through a Google Forms survey. 882 respondents from Ukrainian technical colleges participated in the full-scale study. Among the main limitations, the following ones should be noted. Firstly, was a disinterested attitude of the college management to the issue of teachers' professional competence assessment. Another limitation referred to the attitude of teachers to their professional competence assessment, which could result in the participation of mostly highly motivated, professionally developed and responsible respondents. Consequently, the results of the assessment could be overrated. That must be considered when the program for teachers' professional competence development is being designed for a definite college. Lastly, there was one more limitation which we connected with the potential biases in self-assessment that could also lead to the overrating of the assessment results. To mitigate those limitations, some ways could be suggested. First of all, it was about the strong explanatory work oriented both college managers and teaching staff. The anonymity provided during the process of assessment could also influence positively the results without biases. Now let me go on with the results. The results of the small-scale experiment, teachers' self-assessments and expert evaluations, were statistically processed to determine the coincidence or difference between the data. The results of Pearson's chi-squared statistical test were given as a matrix, Table 1. For that reason, firstly, we had to accept the null hypothesis H0, absence of significant differences in diagnosis employing research and expert methods. Secondly, we could draw such conclusions with a probability of 95%. Thirdly, the absence of significant differences in the results of the assessment by the indicated methods allowed us to conclude about the validity of the developed diagnostic tool, the questionnaire. The last generalization, in our opinion, was extremely important. The peer review, which was used to test the validity of the research methodology, is considered to be an objective procedure. But, at the same time, it is resource-intensive, organizationally cumbersome and relatively long-lasting. Therefore, the statistically confirmed valid diagnostic tool based on self-assessments could be used for extensive experimental studies of the levels of development of the engineering teacher's professional competence. The full-scale study of the levels of development of the engineering teacher's professional competence, 2023, was conducted using a Google Forms survey, which covered 882 respondents from Ukrainian technical colleges. The results of self-assessment by the engineering teachers of their ability to effectively carry out professional activities are presented in the slide. As can be seen from the table, according to respondents' self-assessment, the motivational and value component of professional competence was the most developed among other components. Its average score was 4.19 points. On the other hand, the respondents stated that they did not have enough advanced knowledge in the field of pedagogy, methodology, and inclusive education. So, the average assessment result for the development of the cognitive information component was the lowest, 3.66 points. The diagram visualizes the obtained results and reveals the fact that the level differentiation of respondents according to the cognitive information component of the engineering teacher's professional competence at Ukrainian engineering colleges was the most vulnerable in comparison with other components of the phenomenon. The results of the current research do not contradict the published findings regarding the positive effect of the diagnostic self-assessment, which enables teachers to define needed professional development directions to meet professional standards. At the same time, the diagnostic assessment being an effective tool for teachers' professional growth still must be followed up by other instruments such as peer coaching, self-education, open classes, research and innovative activities. Thus, we could make the following conclusions on the findings. The substantiated tool for diagnostic assessment of the development of engineering teachers' professional competence could be a valid method that enables quick obtaining of data on the engineering teacher's ability to carry out pedagogical activities effectively. The validity of the tool was proved during the experiment when the results of self-assessment, research method, were compared with the expert's results, expert method. Extensive experimental studies have established that engineering teachers at Ukrainian engineering colleges demonstrated mostly high levels of professional development and were sufficiently motivated to organize the educational process, actively master advanced digital technologies, have at a certain level the skills to conduct scientific and pedagogical research and the ability to apply innovative educational technologies. Additionally, the analysis of the self-assessment results revealed that engineering teachers at Ukrainian colleges need advanced, innovative knowledge regarding the organization of the educational process, principles, rules, and conditions of blended learning, methods and forms of teaching students with special educational needs, designing the content of learning, etc. These aspects could be studied for further research. It also must be noted that the obtained results support the concept of college teachers' continuous professional development as one of the effective instruments to facilitate constant teachers' professional growth and provide the sustainability of the educational process. In addition, the ideas of teachers' continuous professional development should be stated as the educational policy and realized in practice using non-formal and informal learning after the proper assessment. That is all. Thank you for your attention.
Dear colleagues, I would like to report our research quality management of training of engineering personnel in the condition of developing their management competence. Authors: Viktor Nagaev, Natalia Moiseyeva, Victoria Novikova, Tatiana Mityashkina, and Sergei Chervony. State by Technological University. Introduction and major challenges. Fundamental changes in the modern socio-economic development of Ukraine require a significant increase in the quality of professional training of engineering personnel in the process of forming their managerial competence. To confirm these conclusions, we will conduct a sociological survey of production works and engineering students of the State by Technological University to determine the role of managerial competence in the production activities of engineers. The results of the survey provide a significant percentage of respondents who provide the high importance of managerial competence of engineering personnel, 76% in the process of their professional training. Aim and research tasks. The research aim is to model the didactic mechanism of the formation of managerial competence of engineers in the system of technological support of quality control of the professional training. Tasks of the research. Functional analysis of professional training of engineers respondent personnel in the process of forming the managerial competence, to form the connect of the structure of the managerial competence of an engineer as a system formation, and to determine its business, organizational, and psychological components. Justification the didactic means of the formation of managerial competence of the engineer in the condition of implementation of pedagogical technology management educational. Justification the stages of duality control of the proposed technological system for the formation of the managerial competence of the engineer in determining its effectiveness. Research methodology. The scientific hypothesis is that the high level of formation of managerial competence of engineers is determined by the high quality of the didactic process of organizing the educational and creative activities of students according to the pedagogical technology management education. The research used modern methodological approaches and adequate theoretical and empirical methods, questionnaires, testing, modeling of creative situation, pedagogical experiment, statistical analysis, reference comparison, in order to substantiate the didactic mechanism of the formation of managerial competence of engineers and control the quality of their professional training. The structure of the pedagogical experiment. The research methodology provides for the condition of ascertaining formative and control stage of pedagogical experiment to determine the effectiveness of quality management of professional training of engineers in the context of the formation of the managerial competence. The research was carried out by the method of survey and questionnaire of the applicants of the State by Technological University specialty agroengineering. teaches production works, postgraduate students, correspondent students, postgraduate students were evaluated in the expert group. Stage of pedagogical experiment. At the assessment stage, the structure components of managerial competence, criteria and levels of its formation, characteristics of a future specialist engineer were clarified. At the formative stage of the experiment, the composition of the control the experimental groups was determined. The result of the self-assessment of the quality of professional training and the formation of the components of managerial competence were analyzed. During the control stage of a pedagogical experiment, a comparative assessment of the effectiveness of the proposed quality management model or professional training of engineers based on the management educational pedagogical technology and the traditional training system was made. The organizational aspect of the experiment includes the development of a step-by-step quality control system for the process of forming the managerial competence of engineers. Conceptual methodology principles. The process of forming the managerial competence of engineers of the new generation should be based on an innovative technological basis which will contribute to a new philosophy of engineering since the development of an adaptive pedagogical system, the equation of new knowledge and technological achievements in educational science and production. A model engineer must have good managerial training, the formation of creative and leadership qualities, the ability to reflect, self-manage and self-development, and develop a methodological base for managing engineers' team. The basis of such changes is scientific management of educational, taking into account the concept of quality renewal of the system of professional training of engineers based on digital pedagogy. Results. Formation of managerial competence in the process of professional training of engineers in the study was implemented according to competence, active and technological approaches. Competence approach relates to the epistemological goal of managerial training of engineers, gaining experience in planning and organizing engineering communication, motivational support of workforce management and control operational activities. The activity approach relates the praxicological goes through the educational activity of the subject regarding the questions of knowledge, skills, and management competence skills. The technological approaches ensure the consistency of operational condition of the organization of the pedagogical process with the aim of guaranteed formation of a high level of managerial competence. The principal model of quality management of professional training of engineers in the condition of formation of the managerial competence. The authors of the study propose to improve the qualitative aspects of the process of training engineering personnel in the pedagogical direction, which is based on the managerial concept of management education. At the basic of this complex management influence, we propose the pedagogical technology management education, which combinations of following components. Conceptual basis, theoretical and methodological foundation of pedagogical technology, motivation part, substantive component, procedural basis, diagnostic part, assessment and analysis of the quality of educational results. Organization of the didactic process according to the pedagogical technology management educational. A necessary pedagogical condition of the formation of managerial competence of engineers is the availability of approachment methods at the integrate organizational forums, practical seminars, webinars, trainings, masterclass, and online consultation, scientific conferences, methods, case method, project method, simulation of management situation, discussion, brainstorming, simulation games, visualization, moderation method, the evaluation of powers. Means educational and methodological complex didactics learning web environment, electronic information research, specialized publication, pedagogical technologies, project training, scientific and methodological support, portfolio management, coaching. Checking for evaluating the levels of managerial competence formation, comparison tables, test, methodological case, evaluation sheets. Monitoring of the level of residual knowledge of students and the quality of the formation of managerial competence according to the management educational technology and the traditional education system. Let's consider the results of the formation of managerial competence of engineers of the example of the discipline agrarian management. The coefficient of residual knowledge was chosen as the criterion indication of the quality level of professional training. According to pedagogical experiment, the researchable knowledge of students who studied using the managerial education technology after 1 year was 78%, and students who worked according to the traditional model 67%. The result of the delayed control also showed positive deviation of quality criteria of managerial competence among students of experimental groups, 24.4% against 33.4% among students of control groups. Qualitative aspects of the formation of managerial competence of engineers in experimental condition. The peculiarity of the formation of managerial competence of the engineers of the experimental group was that the educational process was oriented in the system of self-didactics, self-management of educational and creative activities. Students had the opportunity to individualize the content of training, shows optimal didactic forms, creative implement scientific project on the formation of management skills. Students actively participate in varying forms of learning development, individual educational trajectories, help educational events, prepared research project, participate in the organization of scientific science, learned the educational studio, School of Young Engineer Leader. This organization of this educational process have future specialists the opportunity to acquire practical skills in making managerial discussion to develop of ability to lead an engineering team. Conclusions. The main stage of professional training of engineering personnel, according to the pedagogical technology management education, are motivational and oriented planning and organizational activity, creative, reflective, creative, and developmental. The process quality management model for training engineering personnel according to the pedagogical technology management education ensure the formation of managerial competence of engineers according to such criteria as stretch of knowledge, learning, productive, communicational level, leadership skills, creative direction in making engineering decisions. The overall effectiveness of training engineers under the pedagogical technology management education is 22% higher compared to the traditional educational system. Acknowledgement. The creative team of scientists, the State Biotechnological University, expresses its gratitude to the InterPartner-2022 team for the opportunity to present the result of our engineering and pedagogical research and the harmonized organization of the scientific and practical conference. We see the development of model of organizational design or production situations for the improvement of managerial skills and mathematical modeling of the structure of the components of the managerial competence of engineering personnel as a promotion direction for future search in the field of the formation of managerial competence of engineers. Thank you for attention.
First was the camber line optimization procedure for mixed inflow tubing rotor. Have you any questions to the speaker in chat or online or in hall and so on? Have you?
In the chat, we don't have any questions.
Mm-hmm.
But if it's possible, as one of the co-author of this research, I want to say a big thanks to all organizers of this conference. We are very pleased to be a part of this conference, and thanks to all organizers and participants for listeners. And if you will have the question to us, please, we are also in the contact. We will glad to answer in mail or maybe in private messages. Thank you very much.
I am suggesting this information. We always open to discuss and invitation always to work in Kharkiv Polytechnic University.
There is no question There is no.
No questions.
Hello, my doctor.
Okay.
There is no questions. Now let's go to the next. Report number 2. There is no report number 2. Sidorenko and so on. There is no. It was. We had not this.
It's possible to give a question?
Let's go to the next presentation. This presentation was without sound. That is why I think that there is no question.
I have a question.
You
in
have
this article. No, first question. Vibration. You have vibration in two directions.
I don't see any representatives of this presentations in the chat, so I think you can write direct message, direct question to the representatives of this presentation of this report.
I understand. Okay. I have many questions, but no. In another time.
I think we can go to the next presentation, to the next topic.
Dear colleagues, should I pause and say sincere greetings from our colleagues, Sergei Kuleshov and Anna Ostapenko from two Ukrainian educational organizations. Unfortunately, they can't join our session today. If you have any questions, you can send them emails and they will be really happy to answer them and support the scientific communication. Next presentation is mine, so I'm ready to communicate with you.
Please say me, please, how program you recommended for really education in Ukraine reality?
Thank you. A good question and quite essential question. If you mean, I need some clarification. Do you mean the program with which shows some stages and the content of learning, or you mean the software? What exactly are you speaking about?
No, I understand it's software, but we don't have Ukrainian software. We have many software in the world, but we need to buy this software. What we need to make?
So, as I understand, we are speaking about software. Well, yes, we must confess that we have a great problem with our native, our Ukrainian software, because we need to pay quite a lot, even for Zoom, to have a good version with different hosts, with all the options we need to pay. And if the university or any other educational institution can provide this, I really recommend, because, for example, this program gives a lot of opportunities for teachers to model more or less real educational process. And it means that you can organize real communication, the sessions of questions, the sessions of discussions, but still our strict position is on the in-person communication, face-to-face communication. So we realize that when we have such challenging time, we must use some online formats, but if we want to keep our quality of education at a high level, we need to move to return to face-to-face communication and use all the software which is possible, which is accessible to us, use just to support some functions, some points in educational process, but not change the real communication of a professor and a student in a laboratory or classroom. That's our strong position.
It was okay. It was presentation number what?
6.
Number 6. It was
6
number
in my
6.
mind, yeah.
Okay, number 6. And the last presentation, I remind you.
I'm sorry, but I have a question in the chat, if you don't mind.
Maybe there are questions in chat. I don't know. Yeah.
Yes. Excuse me, dear colleagues. Let me introduce myself to you. My name is Viktor Nagaev, professor of Department Management Administration by Technological University. I would like to ask questions for Olena Titova. Were there any limitations which you considered during the full-scale experiment?
Actually, yeah, thank you for the question. And of course, we considered some limitations. Some of them were expected, and we could predict them. And they mostly refer to the attitude of the teachers to their professional competence level, and there may be some biases according to the assessment of the level. So now I mean that when we were providing a full-scale experiment, we realized that the highly motivated, the highly competent and very active teachers would take part in the survey, and that could lead to the overrating of the results. Still, we asked our teachers to be free and to give us real results, to be strict in their self-assessment. And one limitation was not expected. It was about attitude of not interested attitude of the management of educational institutions, because sometimes the information about our experiment and about our research just didn't reach the respondents, the teachers who could take part in our experiment. And that was a real regret and disappointment. And we tried to work more with the management, explaining the importance and essential things of our experiment. That's it.
Okay.
Thank you. And I would ask first questions for Olena Titova. What prospects do you see in further research on your topic? My question in the chat.
Okay, thank you. Actually, the the further research could be devoted to the development of scientific basis, and then the development of real effective instruments to facilitate constant teachers' professional growth and provide the sustainability of the educational process. So we understand that this must be done together with policymakers in the country, together with educational institutions, professors, and teachers, which participate directly in educational process. So we see a lot of different directions for further research, but first of all, effective instruments.
Okay. Have you any question to our speakers? No, there is no. Now let's go to the last presentation, number 7. I remind you the topic: quality management of training of engineering personnel in the conditions of developing their management competence. Viktor Nagaev, speaker. Yes. Have you any question to Viktor Nagaev?
It's possible to one question, okay?
Okay.
Okay. Victor, I really don't understand what is different your method like management and traditional. Management, it's management in time. It's first question. And what is traditional? I don't know if we don't know what is traditional. In this case, we don't understand what is new in management. What gal your advantage in management?
Thank you for your questions. I help translate from for English into Ukraine. I help Olena Titova.
Sure.
It's possible to Ukrainian, no problem. Да. Можем послушать по-украински. Нема проблем.
Could you say the question in Ukrainian, Professor? Could you say your question in Ukrainian, or could I translate?
Repeat question.
In English better. In English better.
Okay, no problem.
Шановний професор, ви запитали стосовно методів традиційних і ті, які ми використовували при формуванні управлінської компетентності інженерів. Так я зрозумів ваше питання. Дякую. Я коротенько, у нас, якщо я не помиляюсь, на слайді 3.2 і 4.1 були ці висновки, але я хочу наголосити на тому, що для підготовки і професійної підготовки і формування управлінської компетентності ми використовували саме імітаційне моделювання, творчі вправи саме для формування управлінської компетентності, які допомагали б майбутнім інженерам керувати інженерними колективами і формувати навички самоуправління. Тому це, ще раз хочу наголосити, кейс-метод, це управлінські ситуації і ігрове моделювання виробничих ситуацій. Дякую.
Дякую.
Okay.
Thank you very much.
Thank you very much.
Can I ask also, does this approach you use, or is this only idea?
Thank you for your questions. Approach, competence approach, active approach, and technologies approach. Example, the technology approach ensure the consistency of operational conditions of the organization, of the pedagogical process with the aim of generated formation of a high level of managerial competence. Excuse me for my English lessons.
Okay. Have you any?
Let me be also polite and answer to Victor's question. Professor, what qualitative changes in the levels of management competence formation in engineering students have you determined in dynamics from, let's say, bachelor to master level?
Thank you for the questions. Dynamics. The analysis of qualitative changes in the level of formation of managerial competence in dynamics provide the following absolute indicators of changes in the level formation of managerial competence. For experimental groups, increase by 0.44 points, and for students of control groups by only 0.32 points. Thank you.
Okay.
Okay.
We can see some changes. Thank you.
There is no question. I have one question to Victor. There are two kinds of processes. The first, educational process, and the second, technological process. Educational, technological. What is the difference between them? Is this the same or no? Technological process and educational process. What is the difference between them? How do you think?
Thank you for your questions. I help Олена Титова. Якщо я зрозумів, ви запитали нас, що стосується відмінностей нашої педагогічної технології від традиційних методів і підходів навчання. Що стосується технологічного забезпечення педагогічної технології менеджменту освіти, то ми маємо 4 основні етапи. Це етап когнітивний, це етап мотиваційно-діяльнісний, творчо-креативний і розвивальний. І на відміну від традиційних підходів методичного забезпечення, ці етапи вони взаємопов'язані і мають прямий зворотній зв'язок за кібернетичним підходом, який ми використовуємо, і забезпечуються мережевою системою зв'язку і електронними засобами навчання, які реалізують автодидактичні функції майбутніх інженерів, що призводить до формування цифрової компетентності, управлінської компетентності і автодидактичної компетентності в процесі формування професійних якостей майбутніх менеджерів. Дякую.
Okay, thank you. There is no question, yes? Yes, Olena Titova.
Dear Professor Lashin, I don't have a question, but if you don't mind, I have also my own opinion about your question. It's the serious, really important question to every educator and scientist who work in this field of educational engineering education and any education field. You know, you asked a really important thing. Educational process and the technological process.
And technological.
Yes,
okay.
I must confess
yes.
that a lot of fundamental and traditional teachers don't realize how a technological process or technological approach could be embedded into education. And they say it's impossible to realize technology in education. But, you know, it's a kind of multidisciplinary approach when people from manufacture, engineering with engineering background, they put technological approach to education, emphasizing that when we deal with the technology, it means we prepare our student according to a strict and absolutely clear technology with definite stages, with definite results at every stage, which we can measure, describe, and compare with the ethanol. It means we have an educational standard like any product which we manufacture on the plant, and we try to try to achieve the qualities for our student the same as for product which is standardized. So, technological approach to my strict opinion, my strong opinion, will have great prospects. But just in the case when the teachers and students will realize what it is and will prepare a technology which really gives expected results at the end of the education process. That's it.
Okay. Olena Titova, you are beautiful and clever girl. Thank you for your
Thanks,
answer.
girl.
Thank you for your answer. Значит, time is up. Thank you all. Thank you to all participants of our conference and our section of this conference. My best wishes to you. See you not later. See you soon, very soon.
Yes, let's hope to see
you,
very soon.
thank you for your participation in our conference. This is the end of our walk. Goodbye.
Thank you for moderation, for understanding, for questions. And take care.
Okay.
See you next year.
Thank you.
Bye.
Goodbye.
Okay. Good afternoon, dear colleagues. Let me introduce myself. I am head of Department Material Science and Luz National Technical University. I will be conduct this session as a chair, and on behalf of organizer team this conference, I wish you a great spending time during this session and useful for everyone. And I would like to encourage you to be confident and prepare your question in discussion and question session. In our session, we have eight research group sorry, and every study will be present on a YouTube platform. You can find the link in a chat. If our technical support you already yes, it's already here. And after the whole video presentation, we will start our discussion session. It will be after 1 and 30 minutes approximately. Now I think we can start. If you have a question, please ask me. Don't hesitate. Okay, we start. Please keep the time and stay.
Hello, all participants of this conference. We are pleased to present our presentation on the topic highlighted on this slide. Stable development and efficient functioning of the aerospace and aircraft repair industries in any country on the world depends on the use of modern high-quality structural materials. The requirements for these materials are dictated by their operation conditions and the manufacturing technologies used. Certain parts of aircraft engines, research facilities, and automotive components require restoration and frequent replacement due to weight loss caused by oxidation and burnout of the bulk of the metal. Given the shortage and cost of heat-resistant steel and alloys and the difference in metal quality between different global manufacturers, the use of heat resistance coatings can partly solve this problem. It is well known that aircraft engine parts are made of various structural materials, for example, steels, titanium alloys, nickel alloys, cobalt nickel alloys, etc., and operate under difficult operation conditions, including high temperatures. Depending on the parts of an aircraft engine, operation temperature can reach from 600 to 1200 graduate Celsius. Therefore, even modern heat-resistant steels and alloys cannot fully meet the challenges they face. These tasks include first and foremost ensuring heat resistance, specific geometric dimensions and wear resistance throughout the entire period of dimensions and wear resistance overhauls and trouble-free disassembly during scheduled maintenance. In particular, this applies to various types of fasteners like as bolts, studs, and other details of different diameters and lengths. On figure 1, we can see a diagram of typical gas turbine jet engine that can three main parts with different temperature, from low pressure and temperature. It's 1, 2, 3 parts, and more high temperature is 4 parts, and high temperature and high pressure compressions in gas turbine jet engine. The main aim of our work was to study zirconium coatings to improve the heat resistance of aviation materials, which will extend their operation range to temperatures above 1000 degrees centigrade. To achieve this goal, it was planned to study coatings based on zirconium oxide alloyed with nickel and calcium oxide in various proportions. The resulting coatings were to be tested for heat resistance at different temperatures and oxidation processes, and structural changes were to be investigated. For our research, we choose 100 chromium-6 steel, which can be used in tribotechnical components and mechanism. Samples of this steel were made in the form of rings with a diameter of 40 millimeters and thickness of 3 millimeters. The following test coatings were formed on the preparated samples by plasma spraying using a plasma torch by transferring powders sprayed in a gas stream. In a figure 1, we can see 3 rings samples that have a different coating on their surface. The first sample has a zirconium oxide coating with a 10% nickel additive. The second sample contains 30% nickel, and the third sample has a calcium additive on their surface. The samples were numbered and marked as shown in this figure. The 1, 2, and 3 number, and 1, 2, 3 number on the figure. This slide shows us the appearance of the samples that were divided for further experiments. A laser was used for cutting, and the samples were cooled with water to prevent overheating and oxidation. Also, for the convenience of cutting, a special mandrel was made on which the samples were fixed before cutting. In the figure 1, we can see figure A, the mandrel, and figure B, the view of the sample after laser cut. All our studies also including heat resistance test. The sample was heat treated at temperatures of 1000 degrees centigrade, 1100 degrees centigrade, and 1200 degrees centigrade, with exposure time of 6 hours in air atmosphere. The samples were placed in the ceramic boards on a distance from each other in the oven. To investigate the nature of obtained oxides, the infrared spectrophotometry method implemented on a Shimatsu ER-Finity-1 device with a Fourier transformer was used. The samples also were weighed before and after the heat treatment. The average growth of each type of coating and the selected temperature intervals was calculated, and we can see the result this calculated on this table. All samples with a temperature of 1000 degrees centigrade have the lowest weight gain. In general, during heat exposure at temperatures of 1000 graduate centigrade and 1100 degrees centigrade, it can be noted that the samples with calcium coating have the highest weight gain, and the lowest weight gain is observed for zirconium oxide plus 10% nickel that we can see in this table. Let us examine in more detail the structure of the samples subjected to the heat resistance test at sample temperature of 1100 degrees centigrade and 1200 degrees centigrade. Since it is at these temperatures that the greatest increases in sample weight is observed. On figure on this slide, we can see changes in the surfaces after and before our test. There are small inclusions in the form of dark droplets in the surfaces of the coating in some places. It we can see in the figure 1a, structure with small droplets. This, and this. The appearance of the interface between the base metal and the coating looks more or less the same in some areas of different samples. Also, in some areas, there are darkening and visible traces of melting and loosening of the substance. We can see it on the next slide in the figure F and the figure D. On some area, we can see porous craters are noticeable, which may indicate surface oxidation. The darkness areas are clearly visible, have torn contours and contain gray contamination, and in some places with an orange tint. On the next slide, next two slides show us the study of selected samples subjected to the heat resistance test at the temperature of 1200 degrees centigrade. For all the samples presented, the line of demarcation between the coating and the base metal is clearly defined, with a distinct substrate area without unnecessary inclusions and relative uniform. The exception was the samples coated with zirconium oxide plus calcium oxide. After heating to this temperature and to 1100 degrees centigrade temperature, dark craters with uneven edges are clearly visible on its surface. Based on the macroscopic examination of the surface, we can confidently say that this coating is the most defective. Samples that contain 10 and 30% nickel in the coating after heating to both temperature have sharply defined boundaries between the coating, substrate and base material, which is not observed for all samples when heat treated at 1000 graduate. Also, single frozen droplets of unknown origin are observed on the surface of the coating after heating to the same temperature. Examination of the surfaces of the samples using a Shimatsu ER-Finity device with a Fourier transformer shows that after the heat resistant test that we use at the selected temperatures, some oxides and non-metallic inclusions were found on all surfaces. It was silicon oxide and its derivatives, both brittle and compacted, polyacetylene inclusions, ultramarine, tetraethyl orthosilicate, and a number of traces of other polymeric compounds. Some of them could have been formed by the interaction of the components of the original powder, and some by the high temperature of the coating and the atmosphere in which the coating was formed. The last slide shows the main conclusions of our work. In general, the study of zirconium oxide-based coatings deposited by plasma spraying shows that the average weight gain of the study samples was approximately 0.53 grams. The largest trend is observed at a temperature of 1200 degrees centigrade, and the smallest at a temperature of 1000 degrees centigrade. The main conclusions is the best protective properties are observed in the zirconium oxide-based coating with the addition of 10% nickel, and the worst in the zirconium oxide with calcium oxide coating. Thank you very much for your attention.
Thank you very much for this possibility to take part in your highly estimated 6th Grabchenko International Conference on Advanced Manufacturing Processes. I will speak on the calculation of the electrical resistance of a common microelectrode for electrochemical studies of coating. Why this problem is important? Machines and equipment operated in difficult conditions under influences of insignificant mechanical load, high temperature, and corrosive active environment contain abrasive particle, and all these factors intensify the corrosion of metal and their alloys and their coating. To ensure high corrosion resistant and wear resistant of machined equipment and structural elements, new compositions of composite material based on thermodynamically stable solid solution having high hardness are being developed. And for the microelectrochemical studies of material and coating, we need the use of microelectrode with a micron size of the working part, and it leads to an increase in the input electrical resistance of the microelectrode. So we pose such a goal. The analytical assessment of the electrical resistance of electrode of the various geometric shapes, horizontally truncated cone, obliquely truncated cone, and such possible values of the electrical resistance for this shape. Our aim is to evaluate coating protective effect. Corrosion tests are carried out in various environments, including using electrochemical method and wear tests under various friction interaction schemes. For example, sliding friction, successful abrasive wear. In contrast, electrochemical studies using a conical microelectrode provide a much higher spatial resolution and are used both during the formation of coating and to study the protective effect of the coating. To carry out electrochemical studies on the structural component of alloys and coating and to obtain accurate and reliable measurement results, it is necessary to use microelectrode, the diameter of which is smaller than the size of the object being studied. This leads to an increase in the electrical resistance of the microelectrode, which in turn requires the use of the measurement recording equipment with a high input electrical resistance. The analytical study of the electrical resistance of a microelectrode of different shape is main motivation for our study. Our methods. To find the analytical expression for the resistance, we used integral defining the resistance, and this integral was reduced to integral of the inverse of the cross-sectional area of the given figure. An analytical solution of the problem of calculating the electrical resistance is found without assuming that the height of vertical part of electrode is equal to the height of the inclined part of the electrode. For calculating of the improper integral, we used the quad command from the computer algebra system WX maxima. It allows users to choose among 6 pairs of the Gauss-Kronrod quadrature formulas for calculating the integral itself. We will consider 2 cases: a vertical horizontally truncated conical cone and the vertical obliquely truncated conical cone. For vertical horizontally truncated electrode of conical shape, we consider such a calculation scheme. We have H is height of electrode, RL is lower radius, U is the upper radius of the basis of our electrode. Gamma is the angle of inclination. In view of figure 1, we can deduce such formula for calculating the area of such section as I. And if we will calculate resistance of every section and summarize these resistances, we obtain such total resistance. In this formula, we can transit to the integral, and such we obtain exact formula for calculating of electrical resistance by the cross-sectional square area. If we substitute 1 into 3, it is easy to deduce resistance of the truncated conical electrode. For difficult case, we will use more advanced mathematics. We consider a calculation scheme for vertical obliquely truncated electrode of conical shape. In this electrode, we additionally use the inclined plane with angle alpha, and want to evaluate the electrical resistance of such electrode. In view of this figure 2, we can obtain such formula for radius R alpha and height H alpha. The resistance of such cone will consist of 3 terms. The first term is the resistance of horizontally truncated cones, with the radius of lower base equal R alpha and the radius of upper base equals RU. We will denote this resistance by R. Using elementary calculation, it is possible to obtain such formula for resistance R hammer. And the second and the third terms of the electrical resistance of the obliquely truncated cone will be generated as the sections of our cone in figure 2. And it depends on the they are located between the circle of radius RL and the circle of radius R alpha. If we draw parallel planes by this section, we obtain 2 different cases for this section. The first case is the area of the corresponding circular segment is smaller than the area of semicircle, and the second case, the area of the corresponding circular segment is larger than the area of the semicircle. For the first case, using some difficult calculation and consideration, it is possible to deduce such Finnish formula for resistance R1. It is given such integral. And for the second case, analytically, this case is given by this double inequality. And for this case, we can deduce such formula for evaluating electrical resistance. Then the total resistance of an obliquely truncated cone is given as sum of these 3 resistances. we will summarize our results. To calculate the integral R1 and R2, we use the command quag. This command implements a simple, globally adaptive integrator based on the Einstein strategy. We will demonstrate result of our calculation on at the figure 3 and figure 4. Figure 3 demonstrates the dependence of the resistance of the truncated microelectrode on the radius of the lower base of the cone. It is such figure. We see the hyperbolically decreasing of this resistance after some ratio between lower and upper bases of radius. The figure 4 also demonstrates hyperbolically decreasing, but we consider angle of sharpening as variable. Summary: we can be justified that that if angle alpha increase from alpha to pi r 2, the expression for r hammer is a decreasing function of this parameter. But a significant advantage of the using electrode of the considered shapes for electrochemical studies is to ensure an increase in the accuracy and reliability of the result of electrochemical measurement of metal coating, as well as an increase in the productivity of scientific research. In further research, we plan to optimize the sharpening angle to obtain the minimum electrical resistance of the truncated conical electrode. Conclusion: we found an analytical solution to the problem of calculating the electrical resistance of a vertical conical electrode cut by inclined plane without assumption that the height of the vertical part of the electrode is equal to the height of the inclined part of the electrode. Cutting the cone with an inclined plane reduces the electrical resistance of the microelectrode compared to an conventional conical electrode. The resistance decreases hyperbolically with an increasing radius of the lower base. Numerical results demonstrated that the electrical resistance drop equal to 90% for a given inclination angle, and optimal ratio of the smaller base to the greater base of the cone microelectrode is equal to 1/500. Also, a large drop in the resistance of more than 30% is achieved for ratio of smaller base to greater base of cone as 1 to 1000. And optimal inclination angle pi r 2. This will improve the accuracy and reliability of the result of the electrochemical studies. Acknowledgement. I, with my co-author, express our sincere gratitude and respect to armed forces of Ukraine. And also we thank for the financial, also, we thank the National Research Foundation of Ukraine for this financial support of our research. Thank you very much for your attention.
Good afternoon, dear participants. I want to present the results of our research team's work titled Radiofrequency Magnetron Sputtering of Biocompatible Coatings.
In biomedical material science and bone tissue engineering, forming nanostructured biocomposite coatings based on hydroxyapatite has a special role in creating new implant materials with bioactive properties. Calcium phosphate coatings based on hydroxyapatite are used to provide the surface of the metal implant with good osseointegration properties. They can be obtained by various methods, but a promising approach to forming such coatings is the radiofrequency magnetron sputtering method. The advantage of this method is the ability to change and control process parameters in a wide range and thereby obtain a coating with a certain set of properties. A deep literature review showed that not enough attention is paid to the studying patterns of structure and properties of coatings, considering hydroxyapatite during radiofrequency magnetron sputtering. This determines the relevance of this research. Therefore, the study of the microstructure of hydroxyapatite-based coatings will reveal the patterns that determine the nature of the growth of the coatings depending on the sputtering conditions, and find the optimal process parameters that ensure the foundation of coatings with a predetermined structure and properties that meet the requirements of biomedical material science. So, the aim and research tasks you can see on slide. So, for studies of calcium phosphate coatings based on hydroxyapatite, the following substrates were used. There are plates of titanium and stainless steel. Before spraying, the samples were degreased in alcohol. Preliminary substrate preparation was carried out for cleaning titanium plates for various organic and inorganic impurities. Sample preparation for applying calcium phosphate coatings was carried out very carefully, since the strength of the coatings adhesion to the substrate depends on the completeness of the cleaning. So, first the titanium substrate was cut and deburred. Next, the sample surface was sanded with abrasive papers and polished with diamond paste. Then the samples were washed with distilled water for 5–10 minutes and cleaned with ethyl alcohol in an ultrasonic bath for 20 minutes at the temperature of 50 degrees, after which the samples were dried at room temperature. After these operations, the target material was directly sputtered onto the substrate material, and final sputtering operation was cooling the parts and waiting in the vacuum chamber for a certain time. Preparation of the target. A paste-like suspension of synthetic calcium hydroxyapatite mixed with polyvinyl alcohol and water was used as a raw material to prepare the target. The mixture was placed in a titanium mold and subjected to preliminary pressing. Then annealing was carried out in a vacuum furnace at the temperature of 1100 degrees for 2 hours. After sintering, nature cooling was in vacuum to room temperature. To form calcium phosphate coatings, we used a vacuum universal post with a WOOP 5M magnetron source designed for synthesizing objects in a vacuum. The location between the target and the samples mounted on the substrate holder was chosen based on preliminary measurements of coating thicknesses over the entire working area of the substrate holder and was 50 mm. X-ray phase analysis studied the coating structural phase composition and texture. The surface morphology and cross-section of coatings formed on a silicon substrate were studied using a scanning electron microscope. The microstructure and phase composition of coatings formed on titanium substrates were studied in a cross-section using transmission electron microscope. The study of the simple surface was conducted using the atomic force microscopy method, and the mechanical properties test included measurement of nanohardness and modulus of elasticity. So, the presence of the following reflections of hydroxyapatite with a hexagonal crystal lattice was established. X-ray phase analysis showed that the phase composition of the coatings does not depend on the sputtering conditions and the location of the samples in a vacuum chamber. However, a change in the ratios between the integral characteristics of the diffraction maxima, such as intensity, half-weight, position of the center of mass corresponding to the lines with different Miller indices, was observed. The highest intensity of the diffraction lines of the coating formed in argon atmosphere deposited in the center of the substrate holder and corresponds to the reflection from the 002 and 112 planes, which can be characterized as a mixed texture. The calculated calcium phosphate ratio was 1.67, and thus the sputtering target material is crystalline hydroxyapatite of stoichiometric composition. Same studies showed that the coating surface of the silicon substrate is uniform and without visible defects like cracks, pores, etc. According to the observed texture, three types of morphology of hydroxyapatite-based coatings can be distinguished. For coatings of a mixed texture and with a predominant orientation, 002, the main relief elements are islands in the form of dome-shaped grains. This is figures A and B. A distinctive feature of the morphology of coatings is the different amount of dispersion of the grain size distribution. In the first case, there is a scatter in the sizes of structural elements of the coating with an average grain size 100 plus minus 40 nanometers, and in the case of coatings textured in the 002 direction, the formation of identical grain shapes, the average size of which is 120 plus minus 40 nanometers, is also noted. Coatings textured in the 300 direction have a uniform, smooth surface. The morphology of calcium phosphate coatings is directly related to their growth mechanism. Thus, the transition from a mixed texture to the 002 orientation is accompanied by a decrease in the size dispersion of structural elements of the coating surface and an improvement in their anaxial structure. Images of the cross-sectional structure of calcium phosphate coatings formed in the argon atmosphere are presented on slide. The atypical columnar structure, the magnetron coatings, was revealed. The coatings formed outside the zone of target erosion, its figure A, are characterized by large transverse dimensions of the columns compared to the coatings formed in the projection area of the target erosion zone, figure B. The weight of the blocks is 110 plus minus 10 nanometers and 40 plus minus 10 nanometers respectively. In addition, in figure A, nanostructure transition zone can be seen near the interface with the substrate. The absence of the transition part in figure B is explained by the fact that under the energetic influence of ion bombardment in the erosion zone of the target, conditions are realized under which the energy of the atoms is sufficient for diffusion through the surface of the target substrate and form ordered structures in the initial stage of coating nucleation. The term image of the coating with a thickness of 430 plus minus 10 nanometers is shown on slide. The electron microscopic studies of the sample revealed a macrostructure similar to that of the coating formed outside the target erosion zone in an argon atmosphere that shows texture along the crystallographic axis perpendicular to the substrate by X-ray diffraction. The image A shows a columnar grain structure with directional growth. The transverse size of the blocks near the interface is 40-50 nanometers. On the free surface, the grain width is 50-130 nanometers. Structured aggregates consist of subgrains with small disorientations that reflect contrast with a single grain. Microdiffraction B indicates the evolutionary growth of grains. As the thickness of the coating increases, the microdiffraction pattern becomes point-like. The interplanar distances calculated for the observed reflections correspond to the hexagonal hydroxyapatite lattice. Formed coatings have an uniform structure without cracks and pores in all areas. A pronounced texture is characteristic of all types of coatings studied. Coatings of all types have a monophasic hydroxyapatite composition. In measuring the topography of the surface of calcium phosphate coatings, the AFM method was used, which is correct method for determining the topography of the surface with an extension from tens of angstroms to the atomic one. So it was determined the separate calcium phosphate grains with a size of 20 to 300 nanometers are formed in the coating structure, which correlates well with SEM images. The results obtained with the help of electron microscopy also confirmed that there are no pores and morphological defects such as cracks and chips in the coatings throughout the depth. The method of dynamic non-indentation was used to study the mechanical characteristics of radiofrequency magnetron coatings, which simultaneously alloys the determination of nanohardness and Young's modulus of elasticity. Analyzing the table, we can say that calcium phosphate coatings with a thickness of 1.6 micrometers formed in the same mode on different metal substrates have the same hardness and Young's modulus within the measurement arrow, which points to the possibility of applying the same type of hydroxyapatite coatings by the mentioned method or any metal implants. And the second conclusion is that calcium phosphate coatings formed by radiofrequency magnetron sputtering in argon atmosphere have higher hardness and Young modulus on average by 20-25% than those formed in oxygen. The main conclusions of our research can be seen on this slide. The power of the radiofrequency discharge, the bias voltage of on the substrate, the working gas atmosphere, and the sputtering time determine the calcium phosphate ratio in the coating and its structure. Controlling the basic parameters of sputtering, changing the coating structure from amorphous to crystalline components, and the ratio of the main elements is possible. Future studies will be devoted to studying new combination of materials and technologies for obtaining coatings and composites for medical implants. The authors appreciate the support of Research and Educational Center for Industrial Engineering by Sumy State University and the International Association for Technological Development and Innovation. My speech is over. Thank you for your attention.
Composite powder materials and coatings with self-sharpening effect for strengthening, restoring, and manufacturing parts and working bodies of agricultural machinery. By Mykola Denisenko, Olena Devyatko, Roman Yakovenko, and Natalia Kanivets. Part 1. Introduction and Major Challenges. Composite materials, composites, are heterogeneous structures formed by the physical joining of two or more compatible materials that differ in composition, properties, and shape. The properties of the resulting compound differ from the individual properties of the materials that make up its composition. The individual components in a composite must not dissolve or absorb each other in any way. The components of such materials retain their inherent properties, which distinguishes composites from classical structural materials such as alloys. Composite structural materials are characterized by the following features: the presence of components in an amount that ensures the specified material properties, the composition and shape of the material components being determined beforehand, and in powder composite materials, the matrix is mainly metals and polymers. The operating conditions of modern engineering impose stringent requirements on materials that must ensure structural strength with minimum weight and dimensions, reliability and long service life under variable and significant power loads, high and low temperatures, corrosive environments, as well as corrosive and electromagnetic radiation. Today, domestic and foreign research centers have created a huge amount, several thousand, of the latest metal and non-metallic materials that form the basis of equipment, various machinery, and modern weapons. Part 2. Aim and Research Tasks. The aim of this work is to substantiate the rational composition and develop a method for designing impact working bodies of feed choppers made of composite powder material based on complex iron chromium carbide with a self-sharpening effect. The research objectives are as follows: to study the composite powder materials with self-sharpening effect, to analyze and compare the physical and mechanical properties of the developed powder materials of the working bodies of agricultural machinery, to develop a mold for an experimental hammer module for a feed chopper, and to develop a technological process for manufacturing a hammer for a feed chopper by hot stamping of broken billets. Part 3. Research Methodology. The methods of studying parts and working bodies of agricultural machinery are aimed primarily at determining the size and structure of chromium or titanium carbide and the matrix. The influence of dimensional elements on the properties of composite materials and characteristics during the testing operation of feed choppers is determined by their structure. To assess the performance characteristics of materials, prismatic samples were made and tested for abrasive and contact wear. The characteristics of the simulation material used for the accelerated durability tests include sand, clay, sawdust, water, and engine oil. The main physical and mechanical properties are shown in the table. As you can see, the first alloy is inferior in hardness due to the lower amount of carbide in the starting materials, but is superior in strength, especially in impact strength, which is more than doubled. The morphology of the constituent particles that form our composite powder materials was studied using a CamScan 4DV scanning electron microscope. The qualitative and quantitative analysis of the chemical composition was carried out by X-ray microanalysis and energy dispersion on a scanning electron microscope. Part 4. Results. There are several methods of manufacturing high-density structural parts. These include repeated pressing and sintering, hydrostatic, isostatic, and hot pressing, rolling of metal powders, bevel punch and metal shell pressing, hot stamping of porous workpieces, explosive pressing, liquid metal impregnation, and liquid phase sintering. In this study, the shredder parts were manufactured by hot stamping porous billets. The diagram of the technological process of manufacturing impact working bodies, hammers of feed mills with the effect of self-sharpening, is shown in this figure. Powdered alloy mixtures were prepared using standard technology for the production of chromium carbide-based hard alloy mixtures. The modular inserts were pressed under 100 MPa in a steel mold using a P125 hydraulic press. The outer layers of the experimental hammer are made of iron chromium carbide, a material with high hardness and wear resistance. The bearing part of the hammer is made of iron carbide chromium material with lower hardness and wear resistance. The technology involves the operations of pouring powders into the mold in layers, pressing them together, and two-stage sintering, in air at 950 degrees Celsius and in vacuum at 1233 degrees Celsius, and isothermal holding for 45 minutes. A general view of the experimental hammer of the module reinforced with hard alloy inserts is shown on this slide. The structure of the alloy contains 50% iron and consists of a complex iron-chromium carbide and metal phase inclusions. According to quantitative analysis, the metal phase is a carbon ferrochromium and has the following atomic composition: 77.9% iron, 10.9% chromium, and 11.2% carbon. The microhardness of the carbide phase in an alloy containing 50% iron is 13,500 to 14,000 MPa, and that of carbon ferrochromium is 6,150 to 6,200 MPa. This slide shows an image of the formation of the friction surface of the working edge from the self-sharpening effect during the maintenance of feed preparation machines. The composite powder coating has several intermediate layers, each of which performs its own functional purpose. It provides strong adhesion of the multilayer coating to the substrate and materials which are processed, maintains tight adhesion between functional layers, and performs barrier functions, for example, increasing the thermodynamic stability of the coating at high machine speeds. Conclusions. Studies of composite powder materials with self-sharpening effect shows that new composite powder materials have a set of physical, mechanical, and geotechnical properties that exceed the performance of structural materials currently used in agricultural engineering. A technology for manufacturing wear-resistant elements from powdered chromium iron carbide composite materials for the working bodies of feed choppers has been developed. The material is obtained from tungsten-free carbide under conditions of impact and abrasive wear. Production tests have confirmed that the manufacture of parts of the working bodies of choppers for the preparation of compound feed from composite powdered layered materials provides the effect of self-sharpening of the working body blade and an increase in surface life by 6 to 10 times compared to traditional materials. Production of composite parts with a layered working part provides a self-sharpening effect due to the regulating difference and wear resistance of the working edges and core. A distinctive feature of powdered structural materials is their porosity, which can be controlled to manage the physical and mechanical properties of the resulting parts over a wide range. Thank you for your attention. Physical and chemical processes in the surface layers of metal materials in contact with an oxidizing environment. By Олена Дев'ятко, Микола Денисенко, Наталія Канівець, Євгеній Петриченко, and Anatoly Головатюк. Part 1. Introduction and Major Challenges. The scale and significance of the external friction problem is estimated by the fact that about 1/3 of the world's energy resources are spent on overcoming friction. The destructive effect of friction and the overall economic losses of the European Union and the United States caused by machine wear largely determine their technical level, reliability, and durability. A large number of crystal structure defects in the surface layers of friction bodies, as well as temperature increase, cause intensive development of diffusion processes, which leads to changes in the structure, chemical, and phase composition of materials. The physical and chemical interaction of the friction surface with the external environment leads to the formation of films of so-called secondary structures. Secondary structures like oxides have high strength, heat resistance, and low thermal conductivity, which protects the surface of the base material well from destruction and contributes to the development of normal wear. The reliability and durability of machines, mechanisms, and devices is determined mainly by the preservation of the dimensions of their elements, the quality of the friction surface, and the surface strength of friction joints. Part 2. Aim and Research Tasks. The aim of this work is to study the mechanism of formation of secondary structures under conditions of external friction in the presence of an abrasive medium. The research objectives are as follows: to study the patterns of physical and chemical processes in the surface layers of metal materials under abrasive wear of parts of working bodies of agricultural machinery in contact with an oxidizing environment. To analyze the research results, including the conditions of formation and destruction of secondary structures depending on the dynamic parameters of the interacting subsystems. And to conduct electron microscopic examination of friction surfaces combined with micro X-ray analysis of elemental composition using the method of FTIR spectroscopy. Part 3. Research Methodology. Within the framework of mechanical and chemical processes, the presence of an abrasive medium increases the amount of wear by up to 1 order of magnitude, and, in the case of a mechanical form of abrasive damage, by up to 5 to 6 orders of magnitude. After the operating factors, the input data for abrasiveness are abrasive particle size, abrasive concentration, abrasive particle geometry, and abrasive hardness. The outputs are considered to be wear, specific fracture work, and friction coefficients. The work of real machines was studied, and the processes of normal mechanical and chemical wear were reproduced in the laboratory. The influence of certain factors on the patterns of its development was differentially studied, with the value of other factors remaining unchanged. A flowchart of the research process is shown on this slide. All studies of the surface layers of materials were carried out using metallurgical analysis and experimental physics. In this work, we used the method of electron auger spectroscopy as one of the most informative surface-sensitive methods using the GEOL-JAMP10S auger microprobe. The linear dimensions of the topology and microrelief parameters of the friction surface and the mass fraction of elements in the materials were measured using an X-ray microanalyzer REM106I. Part 4. Results. Type 1 secondary structures are solid solutions of oxidizing agents in metals. They have a shiny vitreous film and are plastic and mobile on the friction surface. They can spread and cause damage and form defects in parts. The results of the study of the microstructure and chemical composition of the friction surfaces of nanocoatings showed that a secondary structure of the first type with a thickness of 105 nanometers is formed on them. Oxide layers are present on the surface of the substrate in contact with the working medium. The outer layer has an uneven boundary with the base metal and a thickness of 8 to 25 microns. The inner oxide layer thickens near the grain boundaries. The chemical composition of the inner oxide layer corresponds to the metal base, while the outer layer is enriched with aluminium, silicon, and calcium. In some places, the dense oxide layer is up to 100 microns thick and is not single-phase. In this case, the dense layer consists of iron oxides. While studying wear results, it can be argued that the reduction in wear intensity is due to the formation of iron oxide, which prevents damage to the friction surface. In dry friction, the presence of oxides in the products of wear was found. This is due to the fact that under normal conditions, a protective film of steel component oxides forms on the surface of such steel, which prevents the migration of iron atoms to the surface. The intensity of the iron line on the unoxidized base metal is on average more than 2 times higher than on the oxidized layer. Shear processes play a major role in the destruction of 65G steel, destroying the matrix itself and crumbling iron, titanium, and manganese carbides. The secondary structure of type 1 is a continuous film without significant signs of submicrorelief. The study of the phase composition of the surface layers of all samples showed that compounds of complex iron and manganese oxides, as well as iron carbides formed after heat treatment, are formed on the surface. Type 2 secondary structures are chemical compounds of non-stoichiometric composition. Due to the blocking and strengthening effects of these compounds, type II secondary structures have abnormally high hardness, and elastic deformation occurs mainly by friction. The thickness of the films of secondary structures of type II is within variable limits, and the content of reagents is within 10 to 28% for iron-based alloys. An optimal self-healing microrelief is formed on the friction surfaces, which corresponds to the state of the surface layers and the processes of formation of secondary structures of types I and II. Along with the formation of layers saturated with oxygen and other chemically active elements of the environment, intensive diffusion of carbon, nitrogen, copper, and other less active elements is detected. Secondary structures of type I should be considered as supersaturated solid oxygen solutions in plastically deformed, microscopic surface volumes of metal. The working surface of the composite material is finely fragmented. Thin films passivate the surface, and the penetration depth of these film structures is insignificant, up to 1 micron. When friction of composite materials occurs, the wear resistance and strength of passivation films are higher. The destruction of secondary structures of types I and II occurs at the boundaries or surfaces of the base material and the new phase, where inhomogeneities of various types are concentrated. As a result of the restructuring of the surface layers of the material, the structure adapts to the loading conditions. The movement of the films due to the discrete contact leads to the material destruction only under critical conditions in certain areas of the surface. Conclusions. Reducing and stabilizing friction characteristics is associated with the formation of secondary structures. When forming secondary structures, the friction system concentrates all types of interaction in thin surface layers. Under abrasive conditions, the surface layers of machine parts and working bodies are instantly oxidized to form thin protective films, secondary structures. Wear in the presence of an abrasive medium is accompanied by heat generation, an increase in the density of dislocations in the surface layer, structural transformations, strengthening and weakening of the surface layer. Studies of the microstructure and chemical composition of the friction surfaces of nanocoatings confirm that a secondary structure of type I with a thickness of 105 nanometers is formed on them. Oxide layers are present on the surface of the substrate in contact with the working medium. The outer layer has an uneven boundary with the base metal and the thickness of 8 to 25 microns. At the same time, the inner oxide layer thickens near the grain boundaries. What both types of secondary structures have in common is the ability to minimize surface layer destruction and protect the physical and chemical transformations and prevent the destruction of the underlying layers. Thank you for your attention.
Analysis of the casting method influence on the microstructure of high-speed steel. Introduction and major challenges. In this study, an analysis of the influence of casting method on the microstructure of high-speed steel casting was conducted. The authors explored various aspects related to the steel microstructure, including the use of computer metallographic method to quantitative analysis. The study involved the application of a specialized software package developed on the National University Odessa Polytechnic for processing and analyzing digital image of microstructure. The preliminary results of the research are presented in the work Showcasting and Analysis of Microstructure of Steel Twist Drill Manufacturing through Different Casting Methods. The results include visual representation and double description for features of the microstructures of the casting. The detailed analysis and results contribute to the understanding of the relationship between casting technique and the microstructure properties of the steel. Aim and research task. The object of analysis are features of the tool steel microstructure, the influence of heat treatment parameters, and manufacturing method on its properties. Modern mechanical engineering is characterized by creation of new technologies to improve the quality of cutting tools. A number of work notes that increasing widespread use on new types of heterogeneous materials instead to structure ones. However, the use for the cutting tool manufacturing is not possible. Modern instruments material are quite expensive. During the cutting tool manufacture, for example, in the production of freeze drill by mechanic processing, large volume of instrumental material go into sheet are scrapped. Therefore, it is obvious that there is a need to search for new technologies, conduct alternative analysis, and select the most economic method for the cutting tool production. Let us carry out a corresponding analysis using the example of freeze drill made from HS 652 steel and other tool steels. Research methodology. Analysis of casting method influence on the microstructure of casting made on stainless steel was carried out with computer microscope using quantitative analysis of the microstructure was carried out using computer metallographic method. The results, digital image of microstructure were processed and analyzed using a special software package developed on the Department of Material Science and Engineering Material of National University of Odessa Polytechnic. Processes of microstructure analysis. The original digital image of microstructures material is entered into the complex and the converted to binary. Many cutting material are displayed in the form of contours. Each of them is sequentially proposed. A set of parameters is determined, shape parameters and other. Type is a contour type of contour. Perimeter, contour perimeter. Heights, contour heights. Widths, contour widths. Area, contour area. Center Y, center X, coordinates of gravity center of the contour. Internal and external the radius of the inscribed circle on the circumscribed circle, feature of the contour type, external or internal. At the figure 1 we can see the picture which present elements of analysis of the microstructure of steel with drill manufactured in the form of casting into a water-cooled chill mold. Figure 2 presents a picture elements of the analysis of the microstructure of the steel twist drill manufactured in the form by the way of cutting it in a water-cooled view after annealing. Figure 3 presents the picture and presents the elements of analysis of the microstructure of steel twist drill made from the rolled products. Table 1 presents a study of sample microstructure. There are the characteristics of sample and the structure. Cutting is a water cooling chill mode cast condition. Cast in the water cooling chill mode. Uncooled casting chill mode after thermal processing. Shell casting cast condition. And processes of rolling. Results. The results indicate that the method of casting into water cooling chill mode and shell casting has the greatest influence of the microstructure of high-speed steel casting. Casting produced by three methods demonstrated unacquired structure features such as needless molten seed with solid carbide forming a mesh and fine carbide grains within the grain. After annealing, the structure changed the sorbiter prosthetic with this rapid carbide mesh and small carbides both inside and outside the grain. This casting method showed a significant impact on the formation of the microstructure and properties of high-speed steel casting, emphasizing their importance in cutting tool production. The main technological parameters for casting drill when into water cooling chill mode were identified as a result of researches. Conclusion. The production of drill required controlling the metal blend structure by assessing in the carbide mesh. Research examining how casting methods affect the microstructure of high-speed steel. It showed that in the cast steel, carbides form a continuous network outside the grain. After annealing, the carbide mesh particle breaks and thin, reducing carbide content by about half due to the dissolution in austenite. During hot extrusion, the carbide mesh in fully destroying, leading to a linear arrangement. This configuration is better than in drill produced by shell mode casting, but less favorable than in roller drills, where small rounded carbides are evenly distributed. A slightly higher carbide content, 8% in drill from the cast billet, compared to roller drill 6%, may enhance cutting properties. The analysis suggests that the casting in a water-cooled chill mode is the optimal method for producing dream blend. Thank you very much for your attention.
Hello, my name is Vladimir Sergeyev. I am from the Lutsk National Technical University, Ukraine, and it's a pleasure to me to present our work. It's called Architecture of Online Laboratory for Modeling and Studying the Properties of Structurally Heterogeneous Materials. This work is performed under the supervision of Viktor Dmitrovich Rudь. So, what's the major objectives, major challenges we try and undertake in this work? Structurally heterogeneous materials, they are widely used in mechanical engineering, and it's a power class and wide class of the materials. And the interesting thing is that we could design such materials with unique properties, and they used to be created with powder metallurgy processes. And the big obstacle on researching and designing such materials is because of the classical methods limitations, because it's significantly costs in materials and in time and in human time, yeah. And the way to increase the efficiency drastically is to use the computer simulations models. So stochastic models and Monte Carlo methods could help a lot with designing and researching such materials. And we actually already performed some works to use and used computer-driven imitations consisting of large number of particles. And in this work we extend our research goal to create and to propose architecture of the online laboratory to perform such simulations. These methods are pretty accurate, and they have a broad interest of scientists, and they allow to significantly increase the number of problems solved. So the why actually I'm into the online laboratory, the online application, is because right now web applications propose a rich set of tools for engineers, for researchers, for students, for scientists, and these tools are very widespread, and there are a lot of national programs among the countries, and as well as big companies like IBM and Google. And for example, Google Collaboratory online laboratory application, it's widely used by researchers of machine learning and artificial intelligence, and that's provides a lot of results based on the online collaboration of researchers. And in this work, the architecture and methodology of performing simulation experiments for modeling and researching the technologies and manufacturing parts using powder metallurgy methods are proposed. We propose it to implement as a web application and place it into the internet cloud, so it will be accessible to a wide range of students and scientists, and hopefully to build it on the principles of open source, so it will be useful for the whole society. In our work, we used a standard software development life cycle SDLC methodology. It's very effective in developing the architecture and planning the projects. This methodology involves the next steps. It's determining the types of users. It's called actors of the system. So, for example, a student is one type of actor, and say professor is another type of actor. Say maybe a commercial engineer is another type of actor, and all of these actors has a different motivation and different goals they would like to achieve in the system. That also includes definition of functional and non-functional requirements, building an interaction diagram, or it's also called use case diagram, where all cases of the system usage so they are depicted, and it looks like a finite automaton model where each step connected to the actor it's required to perform. Methodology also involves a decomposition. It's a definition of the main software modules, developing a UI UX framework. It's called mockups, and this helps to predict a design of the system, visual design of the system, how it will look like even before the actual development, and save time and resources. And at the very end, it's building an architectural diagram of the system, because this actually is the primary goal. The main components of the online laboratory, as we found during the decomposition, includes a web user interface, a simulation engine, is client-side based on the modern JavaScript frameworks like React or Angular or Vue.js. A simulation engine server-side, so it decoupled from the client-side to run in parallel and to not block a user. It also cuts files loaders. It's very important because mostly researchers and engineers who work with powder metallurgy and would like to create a new details and parts, they already have their details designed in the CAD system like AutoCAD or SolidWorks or etc. It's also components includes a visualization 3D library to be able to access, experiment and visualize it in real time. This includes Monte Carlo simulation engine, both with a classical distribution and with quantum normal distribution generators, and a particles collision engine to calculate collisions in efficient way. It should be built with a high-performance language like C or C++. This diagram depicts these major components, and each component with mostly primary parts. So on the next diagram, you could see use cases diagrams we developed. So this diagram, this slide shows only the researcher actor, and it's acts in the system boundaries and running experiment, saving experiment, or sharing it, loading detail from the CAD file, using Monte Carlo simulation, or setting experiment conditions such as a percentage of each fraction or friction values for the materials, etc. During our work, we achieved the results. So we proposing an architecture of online laboratory architecture. I'll show it on the next slide. And the most optimal is a cloud web application based on the technology of virtual environments. Architecture on this slide, and this also includes access to quantum computers to generate random numbers for the Monte Carlo simulation based on the quantum normal distribution. It's more close to the natural world. And as you can see, it proposed to have also a database cluster, a load balancing, a container registry, and all other parts that are common in this currently in the standard web applications based on the online cloud. And this schematic is shown a random number generation we developed for the IBM Kyiv quantum computer. It's for 16 of registers and could be increased to up to 127 registers as this processor proposed. Our architecture primary points, so it uses a web user interface. It's decoupled from the REST API running on the background, and it's conforms with all standards such as OpenAPI. It's used persistent data storage, and this provides data redundancy and encryption. It's powered with Monte Carlo and quantum computing devices in the cloud. Conclusions are, so we propose software architecture methodology for performing simulation experiments for modeling and researching the properties of parts designing for production by powder metallurgy methods. A project plan for creating a web application in the internet cloud, and the results of modeling using classical Monte Carlo and quantum computing methods, real-time data exchange, and online collaboration between researchers. We would like to acknowledge the University of Stuttgart for giving us access to Spinning Diamond, a spin photon-based quantum computer. It's based on artificial diamonds, and IBM Corporation for access to Kyiv quantum computer. This is a new quantum computing device which is online from the March of this year. And I would like also thank you for your attention. It's a big pleasure to speak on this conference, and I'm really happy to present the results of our work. This is work still in progress, so our next steps includes actually building such an online laboratory. And if you have any questions, please contact me, Vladimir, or Victor Ruch. We will be happy to help. Thank you for your attention, and have a nice day.
Dear colleagues, we present to your attention a report on the topic of the investigation of J3DKVI alloy as a material of gas turbine engine cast blades. From the group of authors Dmitro Tomkin, Alexei Pedesh, Olena Nomik, Valery Nomik, and Eduard Kondratyuk, who are representing Zaporizhia machine building plant named after Amelchenko, GSK Motor Sich, National University Zaporizhia Polytechnic, and State Enterprise named after academic Ivchenko. Responsible cast of power units in aircraft and power engine operates under a condition of high stress and temperature. They are made of highly heat-resistant nickel alloys. As a rule, these parts are obtained on special installation using equiaxial and directional crystallization methods. Since the alone system of heat-resistant alloys is much overloaded, a rational way to further improve their performance is to use modern technological operations. The J3DKVI alloy is widespread and used for the manufacture of cast fan turbine blades using the equiaxial crystallization method operated at temperature up to 900 degrees by Celsius. The aim of this work is to study the quality indicators of J3DKVI alloy as a material for gas turbine engine cast blades, as well as to assess its balance in terms of a set of alloy elements to determine the suitability for the use of modification technological operations. Modern methods were used in the research. We investigated the material quality of the fan turbine blades cast from the heat-resistant nickel alloy J3DKVI according to the serial technology at Motor Sich JSK. At the UPPF 3M unit, A charge weighing 8 kilograms was melted in the alkaline melting pot to obtain fast working blades, as well as a finger samples. Their chemical composition was determined. We studied the appearance, macro and microstructure of rotor blades and samples. The blades were tested for the bending up to 90 degrees on a manual screw press using special devices with V-shaped recess. The mechanical and heat-resistant properties of the samples were determined after the heat treatment according to the standard regime. Mechanical properties according to the tensile test and long-term test were determined on cylindrical samples with a diameter of 12 mm, and impact toughness was measured on sample with a cross-section 12 for 12 mm, cast by method of equiaxial crystallization. Mechanical properties at room temperature were performed in accordance with ISO 6892-84 standard. Tensile tests were carried out on ZDM30 machine. Sharpie impact bending tests were performed on pendulum copper in accordance with proper standard. Long-term strength test was carried out in accordance with the requirements of also proper standard. On a DST 5000 model installation at a temperature of 850 degrees by Celsius and a load of 350 MPa until complete failure. An indicator of the suitability of an alloy for use of technological modification operation is the level of its structural stability. To assess the structural stability of the origin G3DK alloy, well-known calculation of analytical methods were used, as well as a complex calculation and analytical technique developed at the National University Zaporizhzhia Polytechnic. In the result of carried out studies, it has been established that the chemical composition of investigated rotor blades meets the proper standards. The driven blades consist of the working part itself, the holder, which receives the energy of the hot gas flow and converts it into the energy of the rotating tube, and the fastening element, the tail section, which fixes the blade on the disc of the power unit. The appearance of investigated blades and the source of ultraviolet is shown on the slide. There are no visible surface defects on the casting. Bending tests of working blades were carried out with a gradual increasing in load until bending angle of 90 was reached. No cracks were found in the bending zone. Macrostructure in the cross tail section and axial tail section is shown on the slide. Research has found that the macro grain size in the feather is from 3 to 7 times from 3 to 7 millimeters, which is approximately 2 times less than in the tail section. A metallographic study of microsections cut from blades revealed microporosity of the shrinkage nature in the feather and tail sections. The size of micropores in the feather is approximately 1.5 times larger than in the tail section. To reduce the level of porosity in finished casting, the use of hot isostatic pressing may be recommended. Previous studies confirmed that during hot isostatic pressing of castings, as a result of simultaneous exposure of high temperature pressure, healing of micropores and looses, spots that do not reach the surface located in the internal volumes of metal occurs. The microstructure of rotor blades is a gamma solid solution, strengthened by the intermetallic gamma-slash phase, which with the presence of carbides and carbonate corresponds to the G3DK alloys in the normally heat treatment states and the accepted scale of microstructure. No signs of overheating were found. The dimension of structural components, as well the distance between the axes of the second order dendrites in the further are approximately 1.5 times smaller than in the tail section. The microstructure on finger cast samples are similar to the structure of blades. Mechanical and heat-resistant properties were determined on finger specimens cast by the method of equiaxial crystallization from J3DKVE alloy according to serial technology after heat treatment according to the standard mode. From the obtained result of mechanical tests and tests for long-term strength, it's clear that the mechanical and heat-resistant properties of the examined samples are satisfactory. It meets the requirement of OST. The parameter of structural stability of alloy J3DKVE were determined by calculation and analytical methods. The obtained data indicate a sufficient balance of the original alloy in terms of complex of alloying elements. So, it can be concluded that the J3DKVE alloy is widely suitable for further modification in various ways in order to increase the complex of its physical, mechanical, and operational properties as a material for cast blades of modern gas turbine engines. The next conclusion can be made as a result. The material quality of rotor blades and samples cast from J3DKVE alloy according to the serial technology and equiaxial crystallization, in terms of chemical composition, microstructure, mechanical and heat-resistant properties, complies with the requirements of OST. The dimension of structural component as well as the distance between the second-order axis of dendrites in the further blade and are approximately 1.5 times smaller than in the tail section. It's established that the bending angle measured after the load is removed range from 105 to 110 degrees. No cracks were found in the bend zone. Studies of original J3DKVE alloy structural stability carried out using known calculation and analytical techniques indicate that it's sufficiently balanced in terms of complex of alloy elements and therefore that it's widely suitable for further modification by various methods in order to increase the level of physical, mechanical, and operational properties of critical cast products of aircraft engines. In the future, it's planned to conduct research on the complex J3DKVE alloy modification with rare earth metals, yttrium, and refractory ultra-dispersed particles, TCN, to reduce porosity in finished cast blades and sample. It's planned to use the hot isostatic pressure. Thank you for your attention.
Dear colleague, dear participant, we come back to the main part of our section. It's discussion. I hope everyone is hear me and already go to discussion session. I hope nobody didn't skip nothing important during the presentation session, but if it happened in technical issues, for example, please don't hesitate and ask the question for the representative and now we start session question and answering, and I'm going to remind you the topic each of our presentation, and we will be talking about. The first one is ensuring heat resistance of aviation materials through the use of protective coating based on zirconium O2. Natalia Zaychuk. Dear colleagues, do you have any question? Please. Natalia, your question? Nobody? Maybe I start with first one. Natalia, I wonder about your intention of the future research concerning coating that you mentioned about in your presentation.
Can I speak?
Yeah, of course.
We planned the next our research and made some part of Friedin corrosion test, but not presentation in this work.
Okay, thank you for your answering. I wish you success in your future research.
Thanks.
Okay, anybody else want to ask the Natalia? Please, dear colleague, it's actually the main part of any conference as for me, because we have the possibility to discuss, and in discussion, if it's known, the main idea of the research, and maybe we can to help the presenter to improve your research in the future. Please ask the question. Okay, we going to next presentation, and I will mention the topic. It's a calculation of the electrical resistance of the cone microelectrode for electrochemical studies of coating. Our dear presenter, Andrei Bandura, do you hear me? You present now? Maybe anybody else from the team, research team of this presentation can be attend? No. Unfortunately, we can ask the question. We move the next topic of our presentation. It was presented by Christina Bernardil. Christina, are you here? Okay.
Yes.
Yes, very nice. Dear participant, do you have any question addressed to Christina? Please take the possibility to communicate. Okay, maybe my question. During your presentation, I spotted when you show us a feature of microstructure, and it can seem to me that was a dark zone between your coating layer and substrate layer, and I assume that it could be such a crack, maybe due to the bad maybe adhesion or maybe incorporation of substrate. What do you think about? Do you understand my question? Christina, excuse me, please.
Yes, thank you for your question. In some part, and I understand your question.
Okay, I'm talking about the one dark zone between the your coating layer and the main part, maybe a substrate for which you are quoting about. And one dark zone, it seems to me as some crack, maybe due to a low adhesion, maybe something like this. I don't know. Could you explain what is? Maybe it's not to make the sense. Maybe it just seem me, but I assume it could be some cracks. Okay, maybe can you mention about the adhesion if you studied it between your coating layer and substrate?
Yes, thank you for.
What is going on?
Yes, thank you for your question. I think I understand what you mean about that some second SEM images. Yes, on the slide. Yes, about the adhesion, we do not measure the adhesion, we do not investigate the adhesion, and there is no cracks. What you can see, no cracks.
Okay, thank you for your answer. I think maybe some trouble with the internet in your side because you are still not moving. Maybe some trouble, I suppose, in your side because we don't hear you well, and your image some like fridge for sometimes. Thank you. Dear participant, do you have maybe more question? Okay, Natalia.
For your future research, and are you coating resistant to cyclic impact loads?
Okay, Christina just writing on a chat that due to bad connection in internet don't have the possibility to answer you. Unfortunately, I think we should move. The representatives here, somebody, Mykola Denisenko.
I think there is no Mykola or any of the co-authors here.
Okay. It's pity, but we move to next. The next topic, physical and chemical process in the surface layer of metal materials in contact with a oxiding environment. I think the same situation because
the same team.
Presenter, yeah. Okay, the next one is analysis of the casting methods, influence of the microstructure and high-speed steel. Okay, who presented this research?
This research was presented by Professor Alexander Derevianchenko, but I can't find him in the list of participants, unfortunately.
Maybe somebody from the research team? No? No, unfortunately. Actually, okay, the next architecture of online laboratory for modeling and studying the properties of structurally heterogeneous materials. Volodymyr Sergeyev, I hope, oh yes. Participant, I encourage you to ask the presenter and Victor Ruch, professor, a question. Please, do you have any question? Maybe I start with question and hope you help me. Okay, my question. As for me, in your presentation, it would be perfect if you could show us this virtual laboratory in real state. It's my question. You are using some part of this virtual laboratory, some software, and can provide us with feedback and recommendation which software we can use for training. It's a main idea, I think, in your presentation, to provide the training in online.
Yeah, thank you for question, Mykola. Yeah, I would like to answer this. The idea of the online laboratory, it comes from the during the work on the dissertation, right? And so we developed several standalone models, computer programs, desktop computer programs, right? And last year, where I was involved in the project in Stuttgart University, right? So they showed how they use these online collaboration tools, right, to work in a distributed team, say part of the team in Stuttgart and another part in Australia, for example, right, and they work together on the same problems, and yes, so it's very, very, very beneficial, right? And so this software system is currently we develop it right now, right, and hopefully to host it on the Amazon cloud, and with some maybe a grant program from them, right? So yeah.
Okay, thank you for your answer. Actually, it's a very interesting topic in the future. Of course, education is constantly changed, and the virtual reality, the virtual laboratory, it's a high topic of interest in any education institution around the world. Thank you. I wish you success in your research in the future. And please take the part of our conference in the future. Thank you. Okay.
Can I ask a question? Can I ask?
Excuse me. I'm sorry. Well, of course, dear colleague, please ask your question.
Your research, and I would like to ask a question about the future. I believe that your online laboratory will be improved and will be finished. And what about the future? Is it possible to other universities to receive access and provide some distance online monitoring, modeling of materials?
Українське, я думаю, можна.
Ну, якщо можна на українське, тому що перекладаю мене тільки Володимир Володимирович. Значить, планується яким чином, що
Ми розуміємо українську мову, можна.
Демоверсія буде доступна для всіх бажаючих, так, а потім, якщо це будемо дивитися, як може, і з вашої допомоги, може на комерційну основу якось перевести. Но демоверсія ми плануємо найближчим часом запустити, щоб можна люди попробували, що це таке, і що ми пропонуємо, яким чином.
Thank you very much and good luck in your the transfer of knowledge.
Maybe do you have no? Okay. We already moved to the last topic of our session. Investigation of ZH, maybe I'm not right to explain, S3DKV1 alloy as a material of gas turbine engines cast blades. Okay. For whom we can address our Valery Naumuk. Yes, I'm right. Valery Naumuk.
Yes, you are right.
Okay, okay, I see. Valery, do you hear us? Not answer, unfortunately. Mr. Naumuk, are you here? No.
Maybe technical problem.
Maybe some technical issues, some technical problem. Okay, thank you for your attention. Thank you for presenting great research. I wish, first of all, peace and victory for everyone in this actually severe war. I wish take care about yourself, and I hope in the future we will be, in the near future, we will be have the possibility to meet each other face to face and discuss in during the conference and go on. Thank you.
Thank you very much to session chair, Dr. Mykola Melnichuk. Thank you for your hard work, for your interesting questions.
I too very want to say you many thanks.
Okay.
Mykola, do you have questions?
Questions. Okay. Maybe. I must check. Okay.
I think it's an interesting paper because it's the collaboration between university and company, and it has a practical relevance. So just one question from my side. In the title, it's mentioned know how to. Maybe it's not my proficiency about it, but it is looks unusual. ZHS3DK, it's something special, something secret material or not?
JS3DK it's widespread heat-resistant nickel alloy for responsible cast parts for aircraft engines and land equipment.
But maybe we have to switch it to the standardized, like, for example, for ISO or DIN standards.
You know, alas, for today, it's not exist ISO standard for this alloy. Motor Siege and Progress are using just that OST, which I said. It's just from the 86 year, as I remember. For today, it's valid. For Ukraine, it's only one standard for today for this alloy.
Okay. One question more. Sorry. Main advantages comparatively with well-known alloys in this sphere, using as a coating for gas turbine engine. What is advantages? Maybe some special components, chemical components, maybe some method of forming.
No, it's just a standard alloy. it's I would say it just beginning point for two PhD dissertation of Dmytro Temkin and Olena Naumik. It's a standard alloy, and we trying to find the ways to improve the level of its properties by the using of technological method of modification. It's metallurgical method.
Okay, okay. Thank you, thank you. Mention. Thank you. Natalia, please, your question.
How do you determine heat resistance in that way?
It's by
for our alloys.
It's standard methodic using cylindrical specimens widespread in machine building industries.
Thank you.
but it's the advantage because it was very interesting. Thank you very much for your participation.
Actually, thank you for your effort to organize this conference. Actually, it's important in this time especially. Thank you.
Thanks a lot.
I also like to express my gratitude to the conference organizers for the opportunity. The conference. Thank you very much.
And I would like to remind that tomorrow will be the next day, the final day, and two sessions are planned, and after that will be the closing ceremony. The next edition of the conference, so we invite you to join us and stay with us during the whole day. Thank you very much. Have a safe day, safe night, evening, and